For millions of years, the Earth was ruled by giant dinosaurs, but their rule ended suddenly when a massive disaster struck, and almost all the dinosaurs disappeared. At first, the world was quiet, smoky, and full of ash. But slowly, out of the shadows, smaller animals began to rise. Furry, clever, and fast. These were mammals. With the dinosaurs gone, they saw a chance to grow, explore, and rule the Earth in their own way. This marked the beginning of a new age, one where mammals started to rise, slowly paving the way for the arrival of humans. Before we begin this journey, let us know where in the world you're watching from, and what time it is for you right now. Drop it in the comments below and settle in for a fascinating prehistoric ride. About 66 million years ago, something extraordinary happened, an event so powerful that it brought an end to the age of the dinosaurs. This dramatic turning point in Earth's history is one of the most fascinating subjects studied by scientists today, especially those who focus on ancient life, paleontologists, and the universe, cosmologists. The most widely accepted explanation for this mass disappearance involves a massive asteroid crashing into Earth. Scientists believe this giant space rock, measuring about 10 kilometers wide, roughly the size of Mount Everest, slammed into what is now the Yucatan Peninsula in Mexico. This impact created a gigantic crater, known today as the Chicxulub crater, which is nearly 180 kilometers wide. The force of the impact was unimaginably powerful. It released energy equal to billions of atomic bombs exploding at once. The collision set off wildfires across continents, created towering tsunamis that swept through coastlines, and hurled so much dust and debris into the sky that sunlight was blocked out across the globe. With the skies darkened for months or even years, plants could not perform photosynthesis, the process they use to make food from sunlight. As plants died off, herbivorous, plant-eating dinosaurs began to starve, and the carnivorous, meat-eating dinosaurs that depended on them quickly followed. The entire food chain crumbled. But that's not the whole story. Around the same time, the Earth was also experiencing intense volcanic activity, especially in an area that is now part of Western India. This region, called the Deccan Traps, was overflowing with lava. Over thousands of years, enormous volcanic eruptions poured out lava, ash, and gases into the atmosphere. These eruptions released huge amounts of carbon dioxide and sulfur dioxide, which caused the planet's climate to change dramatically. Carbon dioxide trapped heat in the atmosphere, leading to global warming. Meanwhile, sulfur dioxide mixed with water vapour and fell as acid rain, damaging forests and poisoning water. These changes made an already harsh world even more difficult to survive in. For many living creatures, it was simply too much. Together, the asteroid impact and volcanic eruptions created a deadly environment. The skies went dark, the air turned toxic, temperatures swung wildly between extremes, food became scarce, life on Earth was brought to the brink. This mass disappearance marked the end of the Mesozoic era, the age of reptiles, especially the dinosaurs. But as terrifying as this event was, it also created space for new forms of life to rise. Once the dinosaurs were gone, mammals, who had lived in the shadows for millions of years, began to thrive. Over time, these mammals evolved into many new forms, including eventually humans. Understanding this moment in Earth's history helps us realize how fragile life is, and how closely it is tied to forces that come from deep within the planet and even from outer space. Scientists have worked for decades to piece together the puzzle of what caused the dinosaurs to disappear. They use many different types of evidence, especially from rocks, fossils, and advanced dating techniques. One of the most important clues comes from a special layer of rock found all over the world. This layer, called the Cretaceous-Paleogene boundary, marks the exact point in time when the dinosaurs vanished. It contains a high amount of a rare metal called iridium, a metal that is almost never found on Earth's surface, but is much more common in asteroids. This strange spike in iridium led scientists to suspect that a huge asteroid had hit Earth around the same time. Further evidence came from the discovery of the Chicxulub crater in Mexico. Scientists who studied the rocks in this crater found signs of intense shock and heat, signatures of a massive high-speed impact. The crater's age lines up almost exactly with the disappearance of the dinosaurs, strongly supporting the idea that this was the spot where the asteroid hit. Paleontologists also study fossils, remains of ancient plants and animals, to figure out when different species lived and when they disappeared. By looking at fossils from around the world, they found that many species, especially large dinosaurs, vanished very suddenly. This sudden disappearance matches the timing of the asteroid impact and the volcanic eruptions. Radiometric dating, which measures how certain atoms decay over time, has helped scientists date the rocks and fossils very precisely. By comparing this data with the fossil record and the layers of sediment, researchers have built a detailed timeline showing how life on Earth changed before, during, and after the disappearance. Computer models have also helped. These simulations show how the asteroid impact would have affected the planet's climate. The models predict a nuclear winter scenario, where darkness, freezing temperatures, and acid rain made Earth nearly uninhabitable for many species. Together, all these pieces form a clear and powerful picture. A colossal asteroid, striking Earth with unimaginable force, triggered a chain reaction of disaster. Volcanic eruptions made things worse, and in the end, nearly 75% of all species, on land, in the air, and in the oceans, were wiped out. The age of the dinosaurs came to a dramatic close. This was not the only time in Earth's history when volcanic activity led to mass disappearance. About 250 million years ago, long before the age of dinosaurs, another event known as the Permian-Triassic extinction, or the Great Dying, changed life on Earth even more dramatically. In what is now Siberia, enormous volcanic eruptions created the Siberian Traps, covering millions of square kilometers in thick basalt rock. These eruptions release staggering amounts of carbon dioxide and sulfur dioxide, just like in the Deccan Traps. The greenhouse effect from the carbon dioxide caused the planet to heat up. The sulfur dioxide led to acid rain, which poisoned lakes, rivers, and soil. Ocean temperatures rose and the chemistry of seawater changed, becoming more acidic. Entire marine ecosystems began to collapse. On land, plants and animals struggled to survive in the toxic, overheated environment. The results were devastating. Scientists estimate that up to 95% of all marine life and about 75% of land animals perished. This was the worst disappearance event in Earth's history. The vanishing of the dinosaurs opened the door for mammals to take over, and eventually for humans to appear. In this way, the end of one world became the beginning of another. However, scientists believe the main cause of this mass disappearance was a giant asteroid that slammed into what is now the Yucatan Peninsula in present-day Mexico. The impact was so powerful that it caused fires, earthquakes, and towering tsunamis. But perhaps the most damaging effect came from the thick clouds of dust and debris that rose high into the sky and blocked out the sun. For months, maybe even years, Earth was trapped in a kind of darkness. Without sunlight, plants could not carry out photosynthesis, the process they used to grow and produce food. As plants began to die, the herbivorous dinosaurs, the plant eaters, lost their main food source. And when they died off, the carnivorous dinosaurs, the meat eaters who relied on them, had nothing left to hunt. One by one, entire species began to disappear. The once green world turned grey and lifeless in many places. Forests withered, swamps dried up. The rich ecosystems that had flourished during the age of the dinosaurs crumbled, leaving behind bare landscapes and a planet in crisis. But this wasn't the end of Earth's story. It was a new beginning. Over thousands of years, the dust in the air slowly settled. Sunlight returned. Tiny plants like mosses and ferns began to sprout again, followed by flowering plants that added colour back to the world. Bit by bit, life made a comeback. With the dinosaurs gone, a door opened for other creatures to rise. Mammals, which had mostly lived in the shadows during the age of dinosaurs, now had the chance to explore, adapt, and grow. They began to fill the empty spaces left behind, creating new ecosystems where they could thrive. Birds, which had descended from small feathered dinosaurs, also survived and spread far and wide. This new chapter in Earth's history led to the rise of modern mammals, including much later humans. It also saw the spread of new plants, flowers and trees, creating fresh habitats and new food chains. Life didn't just bounce back, it transformed. More than 66 million years ago, a massive space rock came crashing into the Earth with unimaginable force. That moment, the actual impact was loud, violent, and explosive. But strangely, it wasn't the strike itself that did most of the damage. It was what happened afterward that truly brought the world to its knees. In the days and weeks that followed that single devastating collision, Earth began to shut down. Not in fire or flames, but in silence and darkness. At first, the changes weren't even visible. There were no dramatic explosions or fiery skies. Instead, something far more dangerous crept in quietly. A global chemical unravelling. From the high reaches of the sky down to the deepest parts of the ocean, the entire planet began to fall apart. Not with a bang, but with a fade. This fading marks what scientists today call the KPG boundary, the dividing line between the world of the dinosaurs and the world that came after. It was not just the end of one chapter in Earth's story, it was the start of something far stranger. A winter without snow, a season without an end, and oceans that slowly began to suffocate under a sky they could no longer see through. For tens of millions of years, life on Earth had depended on sunlight. Plants used sunlight to grow. Tiny ocean creatures used it to create food. Sunlight was the engine of the entire planet's ecosystems. But after the asteroid hit, that engine stalled. The sky darkened. The sun's rays no longer reached the surface, and the world began to go cold. Ash and chemicals filled the sky. One of the most important biological processes on Earth, photosynthesis, the way plants and microscopic organisms use sunlight to make food, began to fail. And in the vast hidden world beneath the ocean's surface, something terrifying began to unfold. Silence. Not just the absence of sound, but the disappearance of life. The main cause of this darkness wasn't just dust from shattered rocks. It was something far more insidious. Sulfur. You see, the asteroid didn't just hit any random patch of Earth. It struck a shallow seabed rich in sulfur-containing minerals like gypsum and anhydrite. When the impact vaporized these minerals, they released huge amounts of sulfur dioxide gas. This gas rose high into the stratosphere, where it mixed with water vapor and formed a thin mist of sulfuric acid droplets. These tiny droplets floated high above the weather systems and acted like a giant mirror, reflecting sunlight away from Earth. The result was a planet wrapped in a thin, invisible blanket that blocked the sun's warmth and light. This sulfuric veil didn't go away quickly. Because it hovered above the reach of rain and wind, it lingered for months, maybe even years. At the equator, the place usually bathed in blazing sunlight. Daylight became a gloomy, colourless twilight. At the poles, already dark for much of the year, that twilight simply never lifted. Beneath this murky sky, Earth's climate began to break down, not in one clean motion, but in tangled, chaotic loops. Temperatures dropped, water stopped evaporating, rainfall patterns collapsed, and at the very base of the food chain, the first signs of mass starvation began. Almost every living thing on Earth depends on light. Even animals that don't use it directly rely on something else that does. At the root of the ocean's food web are tiny organisms called phytoplankton. These little creatures take in sunlight and use it to make sugars, creating energy that feeds small fish, which feeds bigger fish, and so on up the food chain. But without sunlight, phytoplankton cannot survive, and without phytoplankton, the entire oceanic food web begins to collapse. Scientists can see evidence of this collapse in ancient layers of ocean mud. These sediment cores, essentially time capsules from the ocean floor, show a sudden and dramatic drop in organic carbon right after the asteroid hit. Fossils of tiny sea creatures called foraminifera, which once filled every corner of the sea, vanish or are replaced by much simpler, hardier types. These newcomers are what scientists call disaster taxa, organisms that thrive in poor, broken environments. They are like the cockroaches of the microscopic world, survivors, but barely hanging on. This wasn't something that happened evenly everywhere. In some coastal areas where nutrient-rich waters rise from the depths, recovery may have started earlier. But out in the open ocean, in the huge swirling central gyres where nutrients are scarce, life stayed dim and broken for thousands of years. The full scale of what happened is hard to wrap our minds around. It wasn't just that there were fewer fish, it was that the logic of life itself stopped working. The biological pump, the system that moves carbon through the ocean, stalled. Oxygen levels in deep water fell. The marine snow, the steady drift of dead organisms and waste that feeds life on the seafloor, slowed to almost nothing. Ecosystems built on that steady flow of nutrients began to starve. On land, a different silence took hold. Plants that had managed to survive the blast now faced something even more deadly: darkness. Without sunlight, they couldn't grow. Forests that had been scorched by fire stopped regenerating. The number of pollen grains in the soil plummeted. In their place, the number of fungal spores exploded. This is what scientists call the fungal spike, a sudden rise in evidence of fungi found in rocks and sediments from places as far apart as North America and New Zealand. But this wasn't a bloom of healthy life. It was a sign of decay. Fungi feed on dead material, and now there was plenty to rot. Life was not flourishing, it was decomposing. Meanwhile, in the sky, more changes were happening. The same sulfuric aerosols that blocked sunlight were also changing the chemistry of the air. As they slowly fell back to Earth, they brought with them acid rain. Not the kind we worry about today, but a much stronger, more widespread version. This acid rain poisoned lakes, rivers, and soil. Freshwater animals, especially sensitive ones like amphibians, were likely among the hardest hit. But much of this damage is hard to see clearly because the fossil record is incomplete. What we do have are clues, shifts in chemicals, gaps in life, signs that something once thriving had vanished. In the ocean, creatures that built their bodies from calcium carbonate suffered terribly. Coral reefs disappeared. Tiny chalky organisms called coccolithophores all but vanished. The ocean became more acidic due to both carbon dioxide and sulfur. This made it harder for these animals to grow shells, affected their body's basic chemistry, and made the ocean a more dangerous place to live. Some of this damage eventually healed, but not quickly. Temporary in geological terms still means thousands or even hundreds of thousands of years. Scientists still debate exactly how long the worst of the darkness and cooling lasted. Some think it may have been just a few months. Others believe it stretched into years with decades of slow recovery. The truth is, we simply don't know for sure. Earth doesn't keep daily records. What we do know comes from scattered clues, layers of rock, chemical signatures, and rare fossils saved in lucky places. However, this was not just a physical collapse. It was an ecological one. The asteroid didn't just kill off dinosaurs. It disrupted the entire system of life so quickly that even the strongest and most successful species couldn't adapt in time. Evolution is powerful, but it works slowly. Extinction, on the other hand, can happen in a single generation. To truly grasp how serious this event was, think about this. Nearly 3/4 of all species on Earth vanished, not just the dinosaurs. Whole families of creatures, ammonites, pterosaurs, most marine reptiles, and even major groups of plankton, all gone. The survivors weren't necessarily the smartest or strongest. Often, they were the smallest, the cold-tolerant, the generalists, or just the lucky. And it all began not with the asteroid's impact, but with the sky. When the clouds grew thick, when the light stopped flowing, when the very chemistry of the air changed, life followed. Not all at once, but unavoidably. The Earth did not become a frozen snowball, but it turned into a cold, dim, chemically unstable world, for long enough to reset life's entire direction. The haunting truth is this: the asteroid struck in just seconds, but its effects rippled through the planet for thousands of years. That is the slow, strange cruelty of Earth's feedback systems. One big shock can push things out of balance, and then the system keeps falling. What came next depended entirely on who managed to survive that long twilight nightmare, but that is a story for another time. For now, we sit in the stillness that followed. Not in fire, not in light, but in silence. The silence of photosynthesis failing, of oceans turning still, of ecosystems holding their breath as if trapped underwater. And the most important question is no longer, how did the dinosaurs die? It is, how did anything live? By around 65 million years ago, the worst part of the disaster that followed the asteroid impact, the long, dark impact winter, was finally starting to ease. The thick clouds of ash and sulphur that had choked the skies were slowly fading. Bit by bit, they had fallen back to the earth as dust and rain. The air was still heavy, but at last a faint, broken sunlight began to peek through. It wasn't warm or bright, not yet, but it was a start. This wasn't a return to normal, far from it. This was the beginning of something entirely new. Earth was still cold, still quiet, and much simpler in terms of life. The once mighty creatures of the Cretaceous period, the towering dinosaurs, the flying reptiles, the ancient sea monsters, were gone. Their bones were still soft and buried in the wet mud. The world they ruled had ended. But even in this quiet, something began to move. Not loudly, not boldly. Life was not roaring back. It was whispering. All over the planet, tucked into hidden corners, under stones, in forest debris, deep inside the ground, tiny creatures were still alive. Not just bacteria or fungi, but animals with bones, with blood, with lungs. Creatures that had somehow made it through the worst days Earth had ever seen. We can't know what they felt, whether they were afraid or confused. Fossils don't record feelings. But they do leave behind patterns, clues in bones and shells, in layers of rock and ancient soil. And those patterns tell a quiet but powerful story. A story not just about death, but about survival. Not the survival of the biggest or strongest, but of the small, the quiet, the overlooked. Today, we often admire the most dramatic animals. Tigers, whales, dinosaurs with teeth like swords. But real evolutionary success isn't always flashy. Sometimes it comes quietly, underground or underwater, in the places no one looks. After the asteroid hit, the creatures that did best were often the ones no one would have noticed at the time. They lived in burrows, cracks in the earth, or along the muddy edges of shrinking rivers. These hiding places had something important in common. They softened the blow. The shock waves of climate change, cold spells, acid rain, falling debris didn't reach very deep into the soil. Underground, temperatures stayed more stable. Inside burrows, the air was cooler and less toxic. In these quiet places, disaster moved a little slower, and the animals that lived there didn't just hide. They were built differently. Many had simple, low-energy lifestyles. Some could hibernate or go into a deep sleep-like state called torpor. Others could handle cold temperatures naturally. During the darkest, harshest times, they didn't run or fight. They waited, not with thought or planning, but with biology, with slow heartbeats, slow breathing, and bodies built to pause. Hibernation isn't magic, but it's extremely useful when the food chain breaks, and there's evidence that some early mammals had already evolved this skill. Not all of them, but enough. When we think of mass extinctions, we often imagine a single moment when everything disappears, but the truth is more complicated. Extinction is not a line, it's a slope. Some creatures may have died in a single day, others faded away over years, even decades, and in the slow fading there was room for the small and hidden to survive. Some amphibians, like frogs and salamanders, seem to have made it through. These animals often live underground or in moist environments, and those micro-habitats may have protected them. They left behind clues in the fossil record, evidence that their diversity didn't suddenly drop. Turtles too, slow and quiet, often living in water, survived surprisingly well. These were not predators. They weren't powerful. They were survivors by nature. Their slow lifestyles, flexible diets, and protective shells helped them through. Among animals with backbones, paleontologists have spotted a strange pattern called the Lazarus effect, where creatures seem to vanish from the fossil record, only to reappear later. This doesn't always mean they died out and returned. It often just means the conditions for preserving fossils had collapsed and later recovered. but it still shows how survival was uneven. Entire groups vanished in some places, while in other places small pockets hung on. These pockets became refugia, safe zones where life's thread could survive long enough to be woven into something new. In the oceans, similar things happened in shallow waters where light and temperature were less stable. Creatures that fed on dead material, detritivores, found enough to eat. Scavengers, filter feeders, and generalists took over where specialists had disappeared. And in the deep sea, around volcanic vents, life continued almost untouched. These ecosystems didn't rely on sunlight. They ran on heat and chemicals from inside the earth. They weren't part of the grand recovery, but they show us something important. Life can come from many places, not just the sunlit ones. We may never know exactly which species made it through those early years. Fossils aren't precise. They don't come with dates marked to the day or even the century. But we can trace the groups, the clades, that survived and changed over time. And what we see is clear. The ones that made it had a few things in common. They were small. They could eat many different things. They could handle stress. And they didn't rely on big, complex ecosystems to survive. That last point matters most. After the impact, the Earth's ecosystems were shattered. Food chains were broken. The species that supported others, like pollinators or keystone predators, were gone. Relationships between species fell apart. The only ones who made it were those who could live alone, or almost alone. Some birds also survived, though not all of them. The older types of birds, those very different from modern ones, mostly disappeared. But the ancestors of today's birds, the ones we now call neornithes, managed to hold on. We don't know exactly why. Maybe birds that lived on the ground had a better chance, or maybe those that ate seeds survived in a world with no fruit and few insects. Either way, the birds that made it weren't impressive. They were scrappy, adaptable, plain. They didn't look like champions, but they were ready for the new world. We must be careful not to imagine a perfect plan here. Evolution doesn't think ahead. It doesn't prepare for disasters. It simply keeps what works in the moment. The creatures that lived through this weren't better. They just fit the new world in just the right way, by chance, not by design. And it was in these narrow, unlikely cracks, in cold burrows, dark soil, quiet coves, that life began again. There is something humbling about that. The grand, powerful creatures were wiped out in what amounts to a blink of geological time. But the ones that dug, crept, scavenged, and slept, they moved forward. Not because they deserved to, but because they could. The ecosystems they helped build were strange. They had low diversity. Most of the animals were generalists, able to eat almost anything. The forests were full of fungi and ferns. The oceans were ruled by slimy mats of microbes. It took tens of thousands of years for complexity to return. But it did, step by step on the backs of the quiet ones. And many of the animals we see today, the birds, the mammals, the reptiles, the fish, they are descended, at least in part, from those survivors. Not in a straight line, not in a clear path, but through deep time, those old lineages branched and bloomed again. But in the very first years after the catastrophe, none of that was certain. The world wasn't planning for the future, it was just trying to hold on. When we talk about extinction and survival, we often focus on big stories, but survival is often small. It's a creature finding the right stone to hide under, an egg buried just deep enough to stay safe, a fish swimming just below the toxic surface. These aren't heroic myths, they're real. They are physics, chemistry, and biology in emergency mode. So the question isn't only who survived, it's what does survival really mean? Maybe it doesn't always look like strength. Maybe it looks like stillness, like sleeping through the darkness, like nibbling dead leaves when nothing else is left, like digging deeper when the sky turns dangerous. In the year 65 million before present, Earth looked nothing like it had the year before. But life was still here, shaken, shivering. But here, the extinction was not total, it was selective, and what it selected were the ones that were small enough, quiet enough, and strange enough to slip through the cracks. The sudden disappearance of dinosaurs wasn't caused by a single reason, but by a mix of terrifying natural disasters. One of the main culprits was a huge asteroid that slammed into what we now call the Yucatan Peninsula in Mexico. This impact released energy greater than 1 billion nuclear bombs, sending clouds of dust and ash into the sky. At the same time, powerful volcanic eruptions in the region we now call India. The sudden disappearance of dinosaurs wasn't caused by a single reason, but by a mix of terrifying natural disasters. One of the main culprits was a huge asteroid that slammed into what we now call the Yucatan Peninsula in Mexico. This impact released energy greater than 1 billion nuclear bombs, sending clouds of dust and ash into the sky. At the same time, powerful volcanic eruptions in the region we now call India poured out massive amounts of lava and poisonous gases. Together, these disasters created a nightmare scenario: scorching fires, choking skies, freezing temperatures, and darkness that lasted for months, if not years. These catastrophic changes wiped out nearly 3 out of every 4 species on Earth, including all the non-flying dinosaurs. But while this spelled doom for many of the planet's creatures, it opened a door for others, especially mammals. Back when dinosaurs ruled the world, mammals were tiny and timid. Most were no bigger than a modern mouse or shrew. They scurried through the undergrowth at night, hiding in shadows to avoid being eaten. But even though they were small and often overlooked, these furry creatures had some important advantages that would soon help them survive one of the worst disasters in Earth's history. Their small size made it easier to hide from danger, and many could dig burrows or find shelter underground. When firestorms raged across the land and freezing darkness gripped the planet, these hidden homes became lifesavers. Also, mammals didn't need to eat large amounts of food to stay alive, and unlike many of the big plant-eating dinosaurs, they weren't picky eaters. Mammals could munch on whatever they could find: insects, plants, roots, seeds, and even small animals. This flexible diet became a major advantage when food became scarce. As the dust slowly settled and sunlight returned to the planet, the world began to heal. But it was no longer the same. The once loud footsteps of the dinosaurs had fallen silent, and a new era was dawning. This era, known as the Cenozoic era, began about 66 million years ago and is often called the Age of Mammals. The creatures that had once lived in fear of dinosaurs now had the space and freedom to spread out, evolve, and explore new environments. In the beginning, most of the surviving mammals were still small. They resembled modern shrews or squirrels, and many of them fed on insects. But over time, as forests regrew and ecosystems recovered, these little survivors began to change. In a process called adaptive radiation, mammals started to evolve into many different shapes and sizes. Some became fast runners, others became strong swimmers. Some grew larger and began grazing on grass, while others developed sharp teeth and became hunters. This great burst of evolution filled the empty spaces left behind by the vanished reptiles. As the climate changed, sometimes warming and sometimes cooling, mammals continued to adapt. When grasslands began to spread across the continents, animals like horses, elephants, and antelope evolved to graze in these open spaces. Predators like big cats and wolves soon followed, learning how to chase and catch them. During cooler times, some mammals evolved thick fur and other adaptations to survive freezing temperatures, especially during the ice ages. This great transformation led to the rise of the modern animals we see today, everything from bats to whales, kangaroos to bears. Among them were a special group of clever social creatures, the primates. Over many millions of years, some primates developed bigger brains and more complex behaviours. Eventually, this line of evolution led to humans, a new kind of mammal that would one day explore the stars and write the story of life itself. But in the middle of this uncertainty, small and furry mammals began to emerge. They were not big or powerful like the dinosaurs, but they were clever, adaptable, and full of hidden strength. These ancient mammals started to take over the empty spaces left behind, exploring new habitats and learning to survive in many different ways. One of the most important changes that helped them thrive was something called warm-bloodedness, or endothermy. Unlike cold-blooded reptiles, which needed the sun to warm up their bodies, these early mammals could keep their bodies at a steady temperature on their own. This meant they could stay active in both hot deserts and chilly forests. Whether it was a freezing night or a stormy day, mammals could keep moving, searching for food, staying alert and outlasting their competitors. This internal heater gave them a powerful edge during times when the climate was harsh and unpredictable. Another amazing change was the growth of fur. This thick, soft covering acted like a natural blanket. It kept early mammals warm during cold nights and protected them from losing too much heat. But fur didn't just help with staying warm, it also helped them hide. With the right colours and patterns, these early mammals could blend into their surroundings, making it harder for predators to spot them. As time went on, their teeth also became more specialised. Instead of having one type of tooth like many reptiles, mammals began to develop different kinds of teeth for different jobs. They had sharp incisors for cutting, pointed canines for tearing meat, and flat molars for grinding plants. This allowed them to eat many types of food, from crunchy insects to juicy fruits, making them even more adaptable to changing environments. But perhaps one of the most impressive changes was in their senses. Many of these early mammals were nocturnal, meaning they were active at night. To survive in the darkness, they needed sharp hearing and a strong sense of smell. Over time, they developed advanced ears with tiny bones that helped them pick up even the quietest sounds, like a rustle in the leaves or the soft footsteps of a predator. Their sense of smell also improved, helping them find food and sense danger even when they couldn't see clearly. These clever and flexible adaptations, warm bodies, furry coats, complex teeth, and super senses set the stage for the rise of mammals. From small rodent-like creatures hiding in the undergrowth, they eventually gave rise to an astonishing variety of species, including bears, whales, primates, and even humans. The journey of mammals is a story of quiet survival, brilliant innovation, and a remarkable ability to adapt to a constantly changing world. The story of how dinosaurs gradually turned into birds is one of the most fascinating and incredible tales in the entire history of life on Earth. It all began about 150 million years ago, during the later part of a time called the Jurassic period. Back then, Earth looked very different, and among the many creatures roaming the land were a group of meat-eating, two-legged dinosaurs known as theropods. Some of the most famous members of this group include the terrifying Tyrannosaurus rex and the fast, clever Velociraptor. But not all theropods were giants. Some were much smaller, and they had something truly unusual for a dinosaur: feathers. Scientists believe these feathers were not just for show. They likely helped with keeping warm, especially as the climate changed. They may also have been used in courtship, allowing dinosaurs to attract mates with colourful displays, just like many birds do today. Over millions and millions of years, these small feathered dinosaurs started to change in many ways. Their bones became lighter and more hollow, making it easier for them to move quickly. Their arms slowly turned into wings. Their bodies became more streamlined, which helped with balance and later with flight. One important change was the development of a strong V-shaped bone called the wishbone, which helped support their wings and made it easier for them to flap and glide through the air. Then, around 66 million years ago, a terrible disaster struck the Earth. A giant asteroid crashed into what is now Mexico, near the Yucatan Peninsula. This impact caused fires, darkness, and a sudden drop in temperatures all around the planet. Most of the dinosaurs, especially the big ones, could not survive these harsh new conditions. It was the end of the age of dinosaurs as we once knew them, but some small bird-like dinosaurs made it through. These survivors were already adapted in ways that gave them a better chance of living. Their feathers helped them stay warm, their wings gave them the ability to escape danger, travel to new places and search for food. Their smaller size meant they needed less to eat, and their lightweight bodies let them move easily through trees, brush, and open skies. They also had clever behaviours that helped them survive. They could eat many different kinds of food, from seeds and berries to insects and small animals. This made them more flexible during times when food was scarce. Some likely lived in groups, which helped them protect each other from predators and find their way when moving across landscapes. And their nesting habits may have helped too. By hiding their eggs in safe places and laying several at a time, they increased the chances of raising healthy young. Because of all these advantages, these early birds, the direct descendants of certain small theropods, didn't just survive, they thrived. As the Earth recovered from the disaster, new habitats appeared, and early birds spread into them. Over time, they evolved into many new species, filling roles left empty by the vanished dinosaurs. Some birds became tiny and delicate like sparrows. Others grew large and powerful like ostriches. Over tens of millions of years, they exploded into a stunning variety of forms. This explosion of bird life is called adaptive radiation, when one group of animals evolves into many different types, each suited to a different way of life. A perfect example of this can still be seen today in the Galapagos Islands, where a handful of finch species changed into over a dozen kinds, each with a different beak shape adapted for eating specific foods. The number of bird species on Earth kept growing and changing over time. Today, scientists estimate that there are around 10,000 different kinds of birds, each with its own unique way of living. Some birds fly thousands of kilometers during migration, while others stay in one place all year. Some have long curved beaks for sipping nectar, and others have sharp talons for catching prey. Their colors, songs, and sizes are just as diverse as their behaviors. The story of modern birds does not end there. Even long after the dinosaurs disappeared, Earth continued to change. Mountains rose, glaciers came and went, rivers shifted, and forests grew or vanished. Birds adapted again and again, showing their remarkable ability to survive in nearly every corner of the world, from icy poles to steaming jungles, and from quiet deserts to crowded cities. One especially important chapter in bird evolution was the rise of Archaeopteryx, which lived about 150 million years ago during the late Jurassic. This creature is often called the first bird because it had a mix of both dinosaur and bird traits, feathers and wings like a bird, but also teeth, claws, and a long tail like a dinosaur. It marked a turning point in evolution, standing at the crossroads between two great worlds. Flight itself likely began with gliding, early bird-like creatures jumping from tree to tree or from rocks to the ground. Eventually, these gliders learned to flap their wings, leading to true flight. Over time, their flying abilities improved, helping them travel farther, avoid predators, and discover new food sources. As Earth entered a new time called the Paleogene period, after the mass extinction, birds really began to shine. They filled forests, coasts, and skies. Some birds became fruit specialists, others became expert hunters, and some learned to crack seeds with strong beaks. Evolution kept sculpting their forms as nature experimented again and again with different shapes, sizes, and behaviors. Even today, birds continue to evolve. Some adapt to cities, learning to eat scraps or build nests in strange places. Others change their migration routes as the climate warms. Some develop new songs or feathers to attract mates. Each one is part of a story that began long ago, when the last of the dinosaurs flapped its feathered limbs and leapt into the air. Whenever we see a bird flying across the sky, whether it's a tiny hummingbird or a mighty eagle, we are witnessing something ancient and extraordinary. That bird carries inside it the legacy of the dinosaurs. From the ashes of disaster came wings, and with those wings the spirit of survival continues to soar. When the mighty dinosaurs disappeared from the Earth around 66 million years ago, it didn't just change which animals ruled the land, it also caused huge changes in the world of plants. This event, known as the Cretaceous-Paleogene extinction, wiped out nearly 3 out of every 4 species living at the time. The loss of these towering reptiles opened the door for many new forms of life, both animal and plant, to grow, adapt, and take over. One of the most important changes in plant life was the rise and spread of flowering plants, also called angiosperms. Before this mass extinction, most plants on land were ferns, cycads, and conifers, plants that do not have flowers and rely on wind or water to reproduce. But after the dinosaurs vanished, flowering plants took center stage. These plants had clever ways to spread their seeds and reproduce, often using animals to help carry pollen or fruits to new places. As a result, flowering plants began to grow far and wide, covering different parts of the planet. Over time, they became the most common type of plant, shaping the beautiful and colourful landscapes we see today. Another major shift was the birth of grasslands. Grasses began to spread into areas that were once filled with ferns and trees. They were tough, able to survive in all kinds of climates, from dry plains to cold steppes, and quickly became one of the most successful plant groups. These grasslands provided rich food sources and open space for many early mammals that were just starting to thrive. With more food and fewer giant predators around, mammals began to evolve into many different shapes and sizes. The back-and-forth relationship between grazing mammals and spreading grasses helped create vibrant new ecosystems full of life. The disappearance of the dinosaurs allowed plants to explore spaces that had once been blocked by giant animals. This opened up chances for incredible variety in plant life, which in turn affected not just animals, but even the climate and health of the whole planet. Today, flowering plants help support nearly all life on Earth. They feed us, provide habitats for wildlife, and are central to farming and agriculture. This shows us how the end of one chapter in Earth's story can lead to the beginning of something even more amazing. The evolution of plants has always been closely tied to the fate of animals and ecosystems. As new kinds of plants appeared and spread, they created new homes and food for other creatures. When flowering plants first began to spread more than 100 million years ago, they transformed the environment. Insects, birds, and mammals found fresh opportunities in the flowers, leaves, fruits, and seeds. Some insects became pollinators, forming strong partnerships with specific flowers. These partnerships helped plants reproduce and made ecosystems more complex and balanced. Different areas of the world began to form into forests, grasslands, wetlands, and other habitats, each filled with its own mix of plants and animals. Plant life started to organize the world in new ways, creating spaces where different creatures could thrive. These ecosystems were like living puzzles, where every species had a job and helped keep things in balance. As Earth's climate changed over thousands and millions of years, plant life kept adapting. During warmer times, certain hardy plants moved northward into colder areas, turning empty, barren land into green forests and grasslands. These changes gave animals new homes and food sources, making food chains more complex and stable. But when certain plant species disappeared, it often caused a chain reaction. Animals that depended on those plants for shelter or food also struggled. This shows how deeply connected plants and animals really are. The ongoing evolution of plant life isn't just about surviving. It's about helping entire ecosystems stay strong and flexible in the face of change. At the same time, with the great dinosaurs gone, insects and other invertebrates had a chance to flourish like never before. These small creatures had once lived in the shadows, but now the world was wide open for them. They quickly spread, evolved, and became even more important in the natural world. Insects especially went through huge changes. With fewer animals eating plants, vegetation grew more freely, giving rise to new plant species. Insects adapted to feed on these plants, leading to a burst of diversity. Some insects learned to eat specific plants, while others became experts in pollination. It was during this time that social insects like ants and bees really began to take over. They formed colonies and developed complex systems of communication and cooperation, creating miniature societies of their own. Other invertebrates, such as mollusks and crustaceans, also saw great success, especially in the oceans. As life in the seas adjusted and stabilized, marine animals flourished. Coral reefs became especially important. These colorful underwater cities, made mostly by tiny invertebrates, grew into some of the most biodiverse ecosystems on Earth, filled with fish, shellfish, and strange sea creatures. So, the extinction of the dinosaurs wasn't just the end of the giants. It was the beginning of a whole new world for small, adaptable life forms. These insects, worms, snails, and sea creatures found new ways to survive and thrive. They filled the empty spaces in the ecosystem, eventually helping to build the modern world we know today. Along with insects and plants, mammals also began to rise. When the dinosaurs vanished, the world became less dangerous for these small, furry animals. They had lived quietly in the background for millions of years, hiding in burrows and moving mostly at night. But now, with fewer predators and less competition, mammals started to grow, change, and explore. Some mammals began to grow larger. Others developed sharper teeth, better hearing, or more advanced brains. They moved into all sorts of new roles. Some became hunters, others gatherers, and many filled niches once ruled by dinosaurs. New predator-prey relationships developed as mammals adapted to chase, hide from, or outsmart one another. At the same time, birds, descendants of small feathered dinosaurs, began to thrive too. With the big reptiles gone, birds quickly evolved into many shapes and sizes. Some became fast flyers, others strong swimmers. Some birds even took on the roles of predators, developing sharp talons and keen eyesight. They spread into forests, wetlands, mountains, and islands, taking over spaces that had once belonged to dinosaurs. Animals that became prey also had to adapt. To avoid the new predators, they got faster, more alert, and smarter. Some learned to live in groups for protection, while others became skilled at camouflage or digging burrows. This constant dance between predator and prey helped shape the animals we see today. Between 58 million and 55 million years ago, the Earth began to find its balance again. After the chaos and destruction caused by the great extinction that ended the Age of Dinosaurs, the world slowly started to heal. The skies were brighter, the land had settled, and plants had returned in full. Life was no longer frozen in a strange post-apocalyptic silence. For the first time in millions of years, Earth felt like a livable place again. Into this quiet but fragile calm, a new kind of creature began to appear. These animals were not big, fierce, or flashy. At first glance, they might have seemed unimpressive, but they had qualities that would change everything. They were clever, quick, and could adapt to nearly anything. The great survivors of the past had waited long enough. Now it was time for nature to try something new. And evolution, with its quiet and often messy creativity, started to favour the small, the fast, and the ones with excellent teeth. This was not yet the time of massive beasts or towering predators. It was the beginning of a very different era, the Age of Rodents. They weren't exactly the rats we know today, the ones that sneak through city sewers and chew on electric wires, but they were their ancestors. They were the early members of a group called the Gliers, which includes rodents and their close relatives. These little mammals began to spread across the lands that would one day be called Eurasia and North America, creeping into forests, burrows, and tree canopies. Though tiny, their arrival marked a quiet but powerful turning point in the history of a life. To understand how rodents became so successful, we have to look at what the world had lost. When the dinosaurs and many other creatures disappeared around 66 million years ago, it was mostly the large animals that couldn't hide or go underground or survive on little food that vanished. The food chains collapsed. Entire ecosystems were left abandoned like ghost towns. The buildings were still standing, but the residents were gone. Whoever came next could take over, and rodents were the perfect squatters. They didn't build the old world, but they moved in and made themselves comfortable. With their simple, flexible diets, fast breeding cycles, and incredibly useful teeth, they were nature's quiet opportunists. By the early part of the Paleocene epoch, we begin to see more fossil remains of small mammals called multituberculates. They are now extinct, but they looked and behaved a lot like modern rodents. Their teeth were specially made for grinding tough plant matter, and they likely filled some of the same roles that today's mice and squirrels do. These multituberculates were already declining, but they showed something important: the value of chewing. In a world full of returning plants and little competition, being able to break down tough food gave mammals a real edge. The rodent-like creatures of the time took this idea and ran with it, literally. Their bodies were built for quick movements. They could scamper, climb, and sneak through complicated landscapes. Their teeth, especially their long, ever-growing front ones, were perfect for constant gnawing. Their brains were small but sharp, helping them avoid danger and find food in an unpredictable world. They weren't kings or queens of the food chain. They didn't need to be. They were background champions, small enough to hide, fast enough to run, and so numerous that they became essential. They were like life's quiet backup plan. One of the most fascinating things about this period is how fast mammals began to diversify. In North America, fossil sites like the San Juan Basin show a growing variety of small mammals, early gliers, insect eaters, and other placental mammals, popping up just a few million years after the mass extinction. In Eurasia, we see the same thing. There were rodents digging in the ground, rodents climbing trees, rodents gnawing on bark, all trying to fit into the spaces that reptiles and birds had not yet taken. Scientists call this burst of life an adaptive radiation, but even that sounds too tidy. What was happening was more like an evolutionary scramble, a chaotic lottery where the main winning ticket was a good set of teeth. Rodents and their relatives didn't win by being the strongest or fastest. They won by being flexible. A rodent could eat seeds, bark, roots, and sometimes even meat. It could live in a tree, a hole, or a patch of grass. It didn't need a stable world. In fact, it thrived when everything was unstable, and the Paleocene world was far from calm. Climate shifts, moving continents, and bursts of volcanic activity kept things changing constantly. While other animals waited for things to settle, rodents jumped at the cracks in the system. They slipped in, adapted, and took over the spaces left behind. One great example of this adaptability is seen in their teeth. While carnivores had sharp blades for slicing, and grazers had flat surfaces for chewing grass, early rodents developed teeth with complex shapes, ridges and bumps, that allowed them to handle a wide variety of foods. That meant that even when the types of plants changed, rodents could still find something to eat. Chewing, it turns out, was one of evolution's best tools. But chewing wasn't enough. Even the best teeth need a safe place to be used. So, alongside their powerful jaws, these small mammals also began to explore new spaces in their environment. Some started living in trees. Their bodies developed features for gripping branches and climbing. Others went underground, digging burrows where they could stay warm, hide from predators, and raise their young. This ability to live in so many different places made rodents nearly impossible to remove. They didn't just live in nature, they lived through it, in every crack, corner, and layer. This great rise of small mammals wasn't happening alone. Insects were evolving too. So were birds. But mammals were quietly changing the game. For the first time in the Earth's history, placental mammals, the group that includes rodents, humans, and many others, were becoming the key players. Not as rulers, but as survivors, as problem solvers, as nature's version of duct tape. Not flashy, but endlessly useful. They could patch, fix, and hold life together. And perhaps one of the most surprising things we've learned is how quickly these mammals began to grow. While most of them were still mouse-sized or rat-sized, their average body size slowly increased throughout the late Paleocene. It wasn't yet the era of huge mammals, but it was the beginning. Evolution was testing the waters, trying out new body shapes. But it started with the safest option: small, furry creatures with strong teeth. There's something quietly revolutionary about this chapter in Earth's story. Dinosaurs had ruled for more than 160 million years. When they disappeared, life could have crumbled with them. But instead, nature chose a different path. It didn't rebuild the old world. It started fresh, with something smaller, faster, and more adaptable. That new approach, based on flexibility instead of power, created a blueprint for survival that would last through every future extinction. The rodents of the Paleocene are long gone. Their fossils are rare, usually just a tooth here, a piece of jaw there, tiny bones, but their descendants are all around us, in forests, in cities, in farms. Mice, squirrels, beavers, porcupines, all of them trace back to this early moment of innovation. In a way, rodents were never the main plan. They were the backup, and sometimes the backup wins. So what happens when you hand the world over to small furry creatures with strong teeth? After the mighty dinosaurs vanished from the face of the Earth, the planet went through a period of astonishing change. The event that ended their reign, most likely a giant asteroid smashing into what is now Mexico, brought about devastating effects. The impact released unimaginable heat and set off enormous wildfires that swept across the land. Then came a long, dark period often called a nuclear winter. Ash, dust, and smoke filled the sky, blocking out the sunlight for many months or even years. Without sunlight, the temperature dropped dramatically. The world grew cold and quiet, with harsh winds and unpredictable weather tearing through once lush landscapes. Plants, which depended on sunlight, began to wither. Entire ecosystems collapsed. Forests vanished, animals died off, and the ground itself started to shift. As ancient seas slowly dried up and pulled back, new land was uncovered, reshaping the map of the world. Strange new geological features began to appear, mountains, valleys, and coastlines that hadn't existed before. Thousands of years later, the chaos began to settle. The temperatures slowly rose again. The skies cleared. Life returned. But it was different now. With the giant reptiles gone, a new chapter in Earth's story began. Mammals, once small and shy, started to multiply and explore the empty spaces. Flowering plants too began to spread far and wide, covering the Earth in green once more. Meanwhile, the great landmass called Pangaea, a supercontinent that had once held all the continents together, continued to break apart. Over millions of years, this slow drifting gave birth to the continents we know today. As these land masses moved across the globe, they reshaped the oceans and changed how currents flowed. This, in turn, affected wind, rain, and temperature across the entire planet, setting the stage for new kinds of habitats where different animals and plants could thrive. Volcanoes also played a major role during this time. In what is now India, a huge region called the Deccan Traps exploded with volcanic eruptions. These eruptions, which happened around the same time as the extinction event, poured out rivers of lava and released massive clouds of gases into the sky, especially carbon dioxide. These gases made the Earth's climate even more unstable, but they also helped shape the landscapes and atmosphere that would define a new geological age, the Cenozoic era. This era, which we are still living in today, marked a turning point in Earth's long and dramatic story. The tale of Earth's atmosphere is equally fascinating. When our planet first formed about 4.5 billion years ago, the air surrounding it was nothing like it is now. In those early days, Earth's atmosphere was filled with light gases like hydrogen and helium, along with poisonous volcanic fumes such as methane, ammonia, and carbon dioxide. This early mix of gases made the planet hostile and unfit for life. And since Earth didn't yet have a strong magnetic shield, the solar wind from the young sun blew much of this original atmosphere away. But Earth didn't stay lifeless for long. As the planet cooled, volcanoes began to erupt more often, spewing out new gases. This process, called outgassing, slowly built a new atmosphere, mostly made of carbon dioxide and water vapour, along with small amounts of nitrogen and other gases. Even though this atmosphere was still not ideal for life, it helped trap heat and keep Earth warm. Then, around 2.5 billion years ago, a truly amazing change began. Tiny life forms called cyanobacteria started using sunlight to make their own food in a process called photosynthesis. As they did this, they released oxygen as a byproduct. Slowly but surely, the level of oxygen in the air rose. This event, known as the Great Oxidation Event, changed the world forever. Oxygen transformed the air, allowing more complex life forms to emerge and survive. Without that transformation, animals, including humans, could never have existed. Over time, the atmosphere continued to change. The slow movement of continents, the rise and fall of mountains, and the evolution of living things all influenced the balance of gases in the air. Eventually, Earth's atmosphere reached a delicate balance, about 78% nitrogen and 21% oxygen. This mixture supports the life we see around us today. It took billions of years to get here, and it could change again if we're not careful. Throughout history, changes in Earth's atmosphere have led to powerful shifts in weather and temperature. Volcanic eruptions, for example, can darken the skies and cool the planet for several years. But in recent times, the biggest change has come from humans. Since the beginning of the Industrial Revolution, a little over 250 years ago, people have been burning coal, oil, and gas in huge amounts. These activities release greenhouse gases like carbon dioxide, methane, and nitrous oxide into the atmosphere. These gases trap heat from the sun, leading to what we now call global warming. But the warming doesn't happen evenly. Some areas get much hotter, while others experience heavy rain, severe droughts, or longer dry seasons. This warming also causes the polar ice caps and glaciers to melt, which raises sea levels across the globe. Coastal cities face more flooding, and some communities may be forced to move. Warmer oceans also make storms stronger. Hurricanes and typhoons are becoming more powerful and damaging. Weather patterns are shifting in strange and unexpected ways. Places that once had regular seasons may now face extreme conditions, making it harder to grow crops, find clean water, or protect wildlife. All of these changes show us just how sensitive and connected our planet really is. The story of Earth is one of constant transformation, a balance between destruction and renewal. And now, more than ever, it is a story that includes us. Over the long and winding story of planet Earth, the climate has never stood still. It has changed again and again, sometimes slowly over millions of years, and sometimes in sudden, powerful bursts. These changes have included shifts in temperature, the growth and melting of glaciers, and dramatic rises and falls in sea levels. Each of these events played a huge role in shaping the way ocean waters move across the globe. During warmer periods in Earth's past, giant glaciers and thick ice sheets began to melt. This meltwater, massive rivers of fresh water, rushed into the oceans. As a result, sea levels began to rise. Land that had once been home to forests, grasslands, and even human communities in later eras slowly sank beneath the waves. Entire coastlines changed, and places that were once dry and full of life turned into underwater worlds. But the story doesn't end with rising water. This huge flow of fresh water also caused major disruptions in how the oceans function. Normally, the ocean works like a giant conveyor belt. Warm water from the equator rises and flows toward the poles, while colder, heavier water from the poles sinks and travels back toward the equator. This system is driven in part by the saltiness of the water, what scientists call salinity. Saltier water is heavier than fresh water, so it tends to sink. But when a lot of fresh water from melting glaciers pours into the oceans, it dilutes the salt content and makes the water lighter. This small change in saltiness may not seem like much, but it can actually slow down or even change the direction of major ocean currents. And because ocean currents help move heat around the planet, any disruption can throw global climate patterns out of balance. These changes don't just affect the oceans, they shape the skies too. When ocean currents slow down or shift, they can change weather patterns. Some places might suddenly become colder and wetter than usual, while others may get hotter and drier. Some regions might face longer droughts, while others might see stronger and more frequent storms. These extreme weather events can damage crops, threaten clean water supplies, and put pressure on both people and nature. All the living things in the oceans, from tiny plankton to massive whales, are also affected. Every species depends on certain conditions like water temperature and salt levels to survive. When those conditions shift too quickly, many sea creatures must either move to new areas, adapt in order to survive, or risk disappearing altogether. This creates a domino effect throughout the food web, as predators and prey struggle to adjust to the new normal. These patterns, melting ice, rising seas, changing currents, and shifting life, have happened again and again across Earth's vast timeline, stretching back hundreds of millions of years. By studying these ancient changes, scientists today hope to better understand the challenges we now face in our own warming world. The more we learn, the better prepared we can be to protect the planet's fragile systems, both in the oceans and on land. By around 50 million years ago, the Earth was no longer burning from fiery disasters or choking on the ashes of the Great Extinction. Instead, it was sweating from the thick, steamy breath of life. The age of ancient devastation had finally quieted down. The planet, left to heal on its own, began crafting one of the richest, wildest, and most experimental ecosystems it had ever seen. It was as if nature had picked up a brush and started painting in bold, chaotic strokes. Rainforests started to stretch their green arms farther north. The amount of carbon in the air went up, helping plants grow faster. Oxygen levels rose too, filling the air with freshness. And in the low, swampy parts of the world, river valleys, tropical floodplains, and warm, soggy basins, something new was bubbling to life beneath the shade of giant leaves. These were lands of still water, tangled roots, rotting wood, and thick, hanging shadows. From the wetlands of what is now Southeast Asia to the swamps that would one day become the American Gulf Coast, a strange, living world was rising from the muck. These wet, murky places didn't just survive the disaster that wiped out the dinosaurs, they thrived, and they changed the rules of life. For mammals, still tiny and mostly unknown back then, This new, sticky, squishy world was the beginning of a revolution. The fossil record from the early Eocene epoch, the time shortly after 50 million years ago, is patchy, like a half-finished puzzle. But even through the gaps, a pattern begins to appear. The wettest parts of the planet had become the most creatively wild. Swamps, bogs, floodplains and tropical wetlands weren't just home to the usual fish and ferns. Life had started to stack itself in layers, growing up into the trees, spreading out along the forest floor, and diving deep into the dark water and roots. Instead of just crawling across the ground, animals now climbed, leaped, and swam through a three-dimensional jungle. Every level of the swamp became a battleground for survival, full of narrow escapes, clever tricks, and fierce competition. Mammals, with their warm bodies, sharp senses, and ability to adjust quickly to new situations, were ready to rise to the challenge. Most of these early mammals were still tiny, often less than a metre long, but their bodies were beginning to change in important ways. We start to see limbs made for grabbing, fingers that could curl and grasp, and claws shaped for climbing instead of digging. Their eyes moved forward, helping them see better in dappled light, and their tails grew longer to help with balance. Even their bones became lighter and more flexible, perfect for weaving through branches, vines, and half-sunken logs. In these tangled wetlands, agility became more than a survival skill. It became a kind of art. Fossil sites like the Green River Formation in what is now Wyoming and the Fur Formation in Denmark give us snapshots of this time. Trapped in layers of shale and mudstone are the outlines of ancient leaves, insects, fish, and occasionally early mammals. One of the most common fossil creatures from this time is a genus called Hyopsodus. It was once thought to look like a hedgehog, but recent studies show it had a surprisingly flexible spine and may have used sound to communicate, much like modern shrews do. It lived in a complex layered habitat, scurrying across the forest floor, perhaps even climbing low plants and hiding in the leafy debris. It wasn't flashy, but it was a sign. Mammals were beginning to use the environment in ways other animals couldn't. So why were wetlands such powerful engines of evolution? For starters, they were full of life, but also full of change. Rain came in cycles, water levels rose and fell, plants grew fast, died and decayed. This meant any creature living in these places had to be flexible, clever, and quick to adapt. You couldn't just have one trick. You needed a whole toolkit. Being an omnivore, eating both plants and animals, was a big help. So was being able to move well. And mammals, with their mix-and-match teeth and fast reproduction, were especially good at trying out new survival strategies. Some clung to tree trunks, others leaped through branches, a few wriggled between reeds and water. This led to a quiet but incredible explosion of new shapes. Long legs, short bodies, paddle-like tails, big eyes. Wetlands became nature's gymnasium, and evolution was in full swing. Another important factor was sound. Swamps and jungles are full of noise, and because thick forests block light but carry sound well, animals that could hear clearly and communicate subtly had an advantage. Many early Eocene mammals show more developed middle ear bones than their ancestors from the Paleocene. This wasn't random. It was evolution answering a deep need. In a world where you might never see a predator or mate until it was too late, hearing could save your life. And as habitats grew more complicated, so did the animals' brains. Mammals didn't just learn to move better, they learned to understand their surroundings. They were starting to build the kind of nervous systems that would one day support imagination, memory, and complex behaviour. But the real star of this new world wasn't a single animal. It was structured. Wetlands created a layered world that had never existed before. Plants divided themselves into upper canopies, middle stories, and ground-level cover. This created hidden pathways and highways for different kinds of animals. The space between water and roots became home for semi-aquatic creatures. Low branches supported climbers and gliders. Higher up, gaps between treetops offered airborne routes. Nowhere else on Earth at that time had such vertical complexity. And mammals, always eager to try new things, rushed to fill every level. Of course, swamps weren't safe havens. They were full of sudden changes, unstable ground, and hidden dangers. But in evolution, danger can mean opportunity. The creatures that learned to balance risk and reward to change their behaviour quickly were the ones that survived. This wasn't just a world of instincts, it was a world that rewarded learning. The plants were evolving too. Wetland forests became rich with flowering plants, many of which depended on animals to spread their seeds or pollinate their flowers. This created complex food chains. Mammals that ate fruit, dug up roots, or hunted insects began finding their own unique roles. And as insect populations grew, so did the number of animals feeding on them. Interestingly, some of the weirdest body shapes didn't come from big mammals that would later rule the open grasslands, but from small wetland mammals that looked like they came from science fiction. Long ankles, tails that could grip, and super sensitive noses were just some of the traits that emerged. In fact, some swamp mammals started looking like tree-dwelling marsupials, even though they weren't related at all. This is a clear sign of convergent evolution, when different animals come up with similar solutions to the same problems. Fossils also show that these mammals came and went quickly. New species appeared, changed, and disappeared in rapid bursts. This tells us these weren't peaceful jungles. They were constantly shifting, fiercely competitive, and full of surprises. Only the most flexible, clever, and quick animals could survive. This was a different kind of evolution, one that didn't reward brute strength, but favoured balance, flexibility, and smart choices. Some early mammals even started returning to water. Signs of semi-aquatic creatures begin to appear: webbed feet, heavier limb bones, nostrils moving upward. These early changes in swamp dwellers hint at a future where some mammals would fully return to the ocean, becoming whales, dolphins, and sea cows. Wetlands weren't just vertical, they were amphibious, and the cleverest mammals began dipping their toes into this new world. But none of this happened with a bang. There was no one animal that stood out as the hero. The real magic was in the slow, steady layering of new behaviours and body shapes. These quiet changes would, over millions of years, allow mammals to spread into every environment on Earth. The swamp wasn't the final destination. It was the training ground, the classroom where mammals learned to climb, to leap, to listen, and to think. Why did the future of mammals begin in the mud? Because mud is messy, unstable, full of surprises, and that's where true complexity is born. In these shadowy, damp, buzzing places, life wasn't just about survival anymore. It was about timing, rhythm, coordination, and cleverness. In the shimmer of light through wet leaves, or the gentle drip of water over roots, the blueprint for future ecosystems was being written. One leap, one glance, one heartbeat at a time. And if you trace the story far enough back, through your own sense of balance, your sharp hearing, your nimble fingers, you might find that you too carry the memory of the swamp, a world where mammals learned not just to survive but to rise. This story of ape evolution wasn't happening in a bubble. The very same forests that gave shelter to early apes were alive with change. Birds were finding new ways to fly. Insects were buzzing through the branches in incredible variety. Flowering plants were blooming in colours and shapes never seen before. And as all these species evolved side by side, they influenced each other in surprising ways. For example, as fruit-bearing trees became more common, primates may have developed better colour vision to spot the ripest fruits. The way the forest canopy changed, growing denser or more open in different places, affected which animals hunted and which ones hid. Even the slow, quiet reshaping of the land by tectonic shifts or changes in rainfall carved the forests into smaller patches. In these little green islands, groups of apes faced different challenges and began to evolve in different directions. When we look back on this chapter of time, we don't see a neat family tree with clear branches. Instead, we see a messy and fascinating sketch, scribbled in fossils and guesswork, of many different apes trying out different ways of life, in different places for different reasons. But even through all this fog and confusion, one thing stands out. Walking upright did not begin on the ground. Some of the body traits we connect with human walking, flexible hips, strong toes for gripping, long limbs for climbing, started in the trees. Being upright may have first helped these early apes climb tall trunks, or reach for fruit rather than walk across the forest floor. So maybe the classic story of human evolution, Apes climbing down from the trees and learning to walk is backwards. Maybe they were already halfway there, upright in the branches, and later brought that posture down to earth. And yet, most of these early apes didn't make it. Despite all their clever adaptations, their flexible joints, their new ways of climbing, most of the ape species from this time went extinct. Climate change, shrinking forests, and competition from other, more specialized animals probably played a role in their disappearance. But a few lines survived. Somewhere in Africa, likely toward the end of this period, the ancestors of today's gorillas, chimpanzees, and eventually humans split off from this wild tree-dwelling experiment. And they didn't survive as rulers of the jungle, but as lucky survivors of a chapter we've mostly forgotten. So what does it take to become an ape? Apparently it takes more than brains or tools. It takes the guts to give up your tail, completely redesign your body, swing through trees in strange new ways, and then hang on long enough for one of your distant relatives to tell your story millions of years later through a glowing screen. The strange part isn't that apes appeared. The strange part is that they lasted. Because in evolution, survival isn't about being perfect. It's about being lucky, finding a niche, and sometimes literally just holding on. But here's a question worth asking. If apes were trying so many different climbing styles, why did only a few survive? Did evolution pick a favourite by chance? Or was the way our ancestors moved through the trees actually better somehow? As the story moves forward, the forest will start changing again, and the pull of the ground will grow stronger. But for now, in the middle of the Miocene epoch, the trees were full of creatures that looked nothing like us, and yet carried the blueprints of everything we would one day become. If you could go back in time, say, between 15 million and 10 million years ago, and walk into the thick, tangled forests of Africa or Europe, you might hope to see the first ape. But chances are you'd miss it. Or more likely, it would be perched 30 feet above your head, watching you silently, wondering what you were doing there. These early apes didn't look like the ones in nature documentaries. They didn't swing dramatically between branches or walk confidently on two legs. They were a jumble of odd shapes. Some looked like monkeys with no tails, others more like sleepy sloths with a fruit addiction. Most were strange evolutionary experiments that didn't quite catch on, and all of them were learning to survive in a forest that had turned into a three-dimensional puzzle of trunks, vines, and shadows. This was the Middle Miocene, a time that doesn't seem very dramatic at first. But something important was happening beneath the quiet canopy. Around 15 million years ago, the planet was warm, not blazing hot like it was after the dinosaurs died, but still much hotter than today. The polar ice caps had shrunk, sea levels were high, tropical forests stretched across huge parts of the world, including places that are now dry and bare. These forests weren't just beautiful, they were complicated. Thick layers of leaves and branches created a world that was full of life and full of danger. For mammals climbing into the trees, there was food everywhere, but only if your body could get to it without falling. And that's where the apes stood out. What truly set them apart from monkeys wasn't how smart they were, or how they used tools, or even how they socialized. It was how they moved. Monkeys kept their long tails and bendy spines, perfect for running along branches. But apes dropped the tail and changed everything else. They began to hang, swing, and climb with their arms instead of just running. To do that, their entire body plan had to change. Their shoulder blades moved to the back. Their arms got longer. Their thumbs became better at gripping. Their lower backs grew stiffer and more stable. These changes helped them explore parts of the forest monkeys couldn't reach, slowly, carefully, and often upside down. But here's the twist. There wasn't just one kind of early ape. From 15 million to 10 million years ago, scientists have found fossil evidence of many different kinds of early apes, now all extinct. There's Morotopithecus, which may have been one of the first to stand upright, found in Uganda and dating back about 20 million years. Then there's Proconsul, which still had a monkey-like back but might have already lost its tail. Later came Dryopithecus, appearing around 12 million years ago in Europe, possibly with better climbing skills and a taste for soft fruit. Its brain might have even been bigger than expected for its size. None of these species were direct ancestors of humans, at least not in a straight line. They were more like cousins, part of a wild tangle of evolutionary experiments. They tried different combinations of climbing techniques, limb sizes and jaw shapes. Most of them ended in dead ends. And sadly, we don't have a lot to go on. The fossil record from this time is frustratingly incomplete. Forest soil doesn't preserve bones well, and many of these apes probably died in places where their remains simply disappeared. What we do have are bits and pieces: teeth, jaws, partial bones. From these fragments we can guess that some species moved slowly like orangutans, while others were more agile. Some were loners, others probably lived in small groups. What this tells us is that life in the trees didn't demand one perfect design. It invited many. It was a constant experiment in what worked best in a vertical world. But then, the fossils start to disappear. In places where Dryopithecus had once been common, only fragments remain. In Hungary, a few survivors lingered for a while. In Greece, an ape called Uranopithecus made one of the last stands. But after about 7 million years ago, almost all evidence of apes in Europe disappears. They didn't migrate east in large numbers. They didn't evolve into something new. They just vanished. And we don't fully know why. There are ideas, of course. Maybe these apes were too specialized for forest life. Their big bodies and slow birth rates made them vulnerable to environmental changes. Maybe monkeys, who were better at surviving in broken, changing forests, slowly pushed them out. Maybe disease wiped out small, isolated populations. But the truth is, we don't have the whole picture. Most of the time, all we find are jaws, teeth and bone fragments. That means it's hard to tell what these apes ate, how they lived, or where they really fit in the tree of life. Some might be close cousins of gorillas or even humans. Others were probably evolutionary offshoots that left no descendants. Still, their absence feels quietly tragic. For millions of years, Europe wasn't just a background for evolution. It was a second birthplace for apes. If things had gone just a little differently, if the climate had stayed warm and wet a bit longer, it's entirely possible that Europe, not Africa, might have been the place where upright apes first began walking on two legs. Or maybe that already happened, and the fossils are simply gone. One mysterious site in Greece, called Pikomi, dates to about 8 million years ago. Among the bones of giraffes and elephants, scientists found ape fossils with strong jaws and teeth that look oddly human. But the remains are too few, too broken, and too uncertain to say for sure what they were. And so the story ends, not with a bang, but with a slow fading away. The trees thinned, the climate dried, forests shrank into isolated green islands, and then disappeared. Without a continuous canopy to feed, shelter, and connect them, the apes vanished too. This wasn't just a tragedy for apes, it was part of a larger change. As the forests disappeared, new ecosystems took over. Scrubby woodlands, open grasslands, and plains full of running animals like horses and antelopes replaced the old forest kingdoms. Insects changed, birds changed, carnivores changed, but the apes didn't change fast enough, and so they faded away. There's a lesson in this. Evolution doesn't always reward the strongest or smartest or most adaptable. Sometimes it just rewards whoever's in the right place at the right time. For millions of years, Europe's apes tried. They climbed, they adapted, they lived. And when the forests vanished, they disappeared. Not because they failed, but because the world they were built for collapsed. And that leaves one final unsettling thought. How many strange evolutionary experiments are still out there today, living in quiet corners of the world, species we walk past every day, never realizing they were once real contenders? But while this extinction marked a tragic loss for the towering reptiles that had ruled the Earth for millions of years, it also cleared the way for a new chapter to begin. With the dinosaurs gone, the world was full of open spaces and new opportunities. Small, furry mammals, creatures that had lived quietly in the shadows while dinosaurs dominated the land, began to step into the spotlight. At first, these mammals were tiny, fast-moving, and not very noticeable. But now, without giant predators chasing them, or bigger creatures out competing them for food, mammals began to grow, change, and explore new environments. Over the next many millions of years, they spread into forests, grasslands, deserts, and even oceans. Some began to walk on land while others took to the trees. Slowly but surely, mammals developed new features and behaviours that helped them survive in all kinds of conditions. Among these early mammals were the ancestors of primates, the group that includes monkeys, apes, and eventually human beings. These early primates were small, clever creatures that lived high up in the trees of ancient forests. Life in the treetops came with new challenges, jumping from branch to branch, spotting food among leaves, and caring for young in high, leafy nests. To survive, these animals needed good eyesight, flexible hands, and quick thinking. Over time, their brains grew larger, their social lives became more complex, and they began to use tools and communicate in more advanced ways. As the climate shifted and new types of forests and landscapes appeared, primates continued to evolve. Some climbed down from the trees and learned to walk upright, freeing their hands to use for gathering, holding, and building. These changes eventually led to the rise of early humans, our distant ancestors. The disappearance of the dinosaurs was not just the end of one era, it was also the beginning of another, a time when mammals took centre stage and began a long, winding journey of evolution. Without that extinction event, the world might never have seen the rise of human beings. It's a powerful reminder that from great destruction can come new beginnings, and that all life on Earth is deeply connected across time, from ancient reptiles to modern humans. By the time Earth reached the Eocene epoch, which began around 56 million years ago, an exciting chapter in our evolutionary story was unfolding. This was the time when the first true primates, also called euprimates, or early primate ancestors, made their appearance. These small, tree-dwelling creatures showed remarkable changes that set them apart from earlier mammals. They had hands that could grasp, which helped them hold onto branches and pick fruit. Their eyes faced forward, which allowed them to judge distance more accurately, a very helpful skill when leaping from branch to branch in the forest. They also had larger brains compared to their body size, helping them become smarter and more aware of their surroundings. These early primates thrived in the lush, tangled forests of ancient Earth, where climbing trees, searching for food like insects and fruit, and avoiding predators required agility and quick thinking. They laid the foundation for an extraordinary journey, one that would eventually lead to humans. As we move forward in time to the Oligocene epoch, beginning about 34 million years ago, we see another big leap in primate evolution. This is when the first anthropoids, a group that includes the ancestors of monkeys, apes, and humans, began to appear. These primates were even more advanced, and they started splitting into two major groups. One group travelled to what is now South America and became known as the New World monkeys. They developed prehensile tails, which acted almost like a fifth hand, allowing them to swing easily through the treetops. The other group stayed in Africa and Asia and became the Old World monkeys and apes, including the ancestors of gorillas, chimpanzees, and eventually humans. This branching out into different continents was a turning point. Each group evolved in its own way, adapting to the food, climate, and challenges of their environments. This led to an explosion of diversity in the primate family. Then came the Miocene epoch, starting around 23 million years ago, and with it, the rise of a very special group, our own ancestors, known as hominins. One of the biggest and most important changes that happened during this time was the development of bipedalism, which means walking on two legs. This simple shift changed everything. By standing upright, early hominins could see over tall grasses, use their hands for carrying tools and food, and travel longer distances more efficiently. But why did this happen? To understand that, we need to look at how Earth itself was changing. During this period, continental drift and climate changes dramatically altered the landscape. Some areas that were once covered in dense forests became dry, open savannas. Around 6 million years ago, Earth's climate became less stable. Some places turned into deserts, while others grew into thick green forests. These environmental shifts forced early hominins to adapt or die. In the new savanna environments, forests were farther apart, so hominins had to walk greater distances to find food. Walking on 2 feet helped them save energy, spot dangers, and even carry food back to their group. One of the early species that lived during this time was Australopithecus, a hominin that balanced both tree climbing skills and life on the ground. the changing world also affected what these early humans ate. As forests disappeared and the environment became more open, the types of plants and animals available for food changed. Early hominins had to become flexible eaters, learning to dig for roots and tubers, gather wild fruits, and eventually hunt small animals. Eating a wider range of food gave them more energy and nutrients, which helped their brains grow larger. A bigger brain allowed them to think more clearly, communicate better, and work together in groups. These social changes were just as important as physical ones. Sharing food, building shelters, and using basic tools made of stone and wood helped early hominins survive in a world full of dangers. They began forming stronger bonds with one another, creating the early forms of cooperation and community that we still rely on today. As they continued to spread into new territories, different groups of hominins met new challenges, different climates, new predators, and unfamiliar plants and animals. These conditions pushed them to adapt in new ways, leading to a variety of hominin species, each with its own unique traits. Some became better hunters, others better toolmakers. Eventually, one of these branches led to the appearance of Homo sapiens, the species we belong to. All of this, the walking, the thinking, the changing diets, the teamwork, was shaped by the ever-changing earth beneath their feet. From the forest to the grasslands, from the ancient primates of the Eocene to modern humans, the story of evolution is a grand journey of survival, adaptation, and creativity. It all began after the dinosaurs disappeared, roughly 66 million years ago, when a massive asteroid struck the Earth and caused a dramatic mass extinction. This devastating event wiped out nearly all the dinosaurs, but it also gave early mammals a chance to rise. With fewer predators and new spaces to explore, these small mammals began to thrive. They faced many challenges in this new world. The Earth's climate kept changing. Sometimes it was warm and lush, other times cold and dry. These changes pushed mammals to evolve quickly. Some grew faster and more nimble, helping them escape predators or catch prey. Others began to live in groups, which gave them safety in numbers and better chances to find food. Little by little, these mammals became smarter. Their sense of smell improved, their brains grew, and they started to behave in more complex ways. They began using tools, communicating through sounds and gestures, and even taming fire. These skills made life easier and helped them form close-knit groups, sharing knowledge and working together. The most important change of all may have been bipedalism, walking upright on two legs. This freed up their hands for carrying, building, and tool-making. It also helped them move across open plains more easily, spotting danger and travelling farther. As early humans spread across the globe, adapting to deserts, mountains, jungles, and icy lands, they created cultures, families, and societies. From a small tree-dwelling primate in a warm Eocene forest to the spacefaring humans of today, our story is one of incredible transformation, shaped by the Earth, challenged by nature, and driven by the endless will to survive and grow. About 55 million years ago, the Earth went through a wild and extraordinary chapter in its history, a time known as the Paleocene-Eocene thermal maximum, or PETEM for short. This wasn't just a brief heat wave, it was a global temperature spike that lasted for around 100,000 years, a blink of an eye in geological time, but long enough to change everything. During this intense warming period, the planet's average temperature climbed by about 6 degrees Celsius. That might not sound like much, but for the natural world it was massive. It meant warmer oceans, changing rainfall patterns, and habitats shifting in every direction. All across the globe, plants and animals had to either adapt, move to cooler areas, or face extinction. What caused this dramatic heat surge? Scientists believe it was mostly due to a huge release of greenhouse gases, especially carbon dioxide and methane, into the atmosphere. These gases likely came from volcanic eruptions, the thawing of frozen methane beneath the seafloor, or possibly even wildfires and changes in the Earth's carbon cycle. Whatever the cause, the result was the same, a planet heating up fast. As the Earth warmed, ecosystems were thrown into chaos. Forests grew in places where they hadn't before. Oceans became more acidic, hurting tiny sea creatures that built their shells out of calcium. These conditions forced animals to migrate, change their behaviour, or evolve to survive in their new surroundings. And yet, from this chaos came opportunity. The PETM turned out to be a turning point for life, especially for mammals. As the climate warmed and new environments opened up, mammals began to rapidly diversify. Many of today's mammal families, like those leading to horses, primates, and deer, began to appear during this time. They thrived in the warmer climate, exploring new food sources and habitats. It was in many ways the beginning of the mammal-dominated world we live in today. But not every species did so well. In the oceans, life was more fragile. Some marine animals, especially those that depended on building shells, struggled with the warmer, more acidic water. Whole groups of sea creatures shrank in number, and some vanished completely. The PETM reminds us how sensitive life is to temperature and chemical changes in the environment. This time of transformation was part of a larger chapter in Earth's story known as the Paleogene period, which lasted from about 66 million to 23 million years ago. It followed one of the most devastating and dramatic events in Earth's history, the extinction of the dinosaurs. When a massive asteroid slammed into Earth about 66 million years ago, it wiped out nearly all dinosaurs and many other forms of life. But once the dust settled and the fires died down, life found a way forward. Without the enormous dinosaurs roaming the land, smaller creatures, especially mammals and birds, had the freedom to evolve in new and exciting ways. Mammals, which had been small and mostly hidden during the age of dinosaurs, began to grow in size and take on all sorts of new shapes and behaviours. Some became swift runners, others turned into powerful predators, and still others adapted to life in the trees or even in water. Early forms of whales, elephants, and primates appeared, each experimenting with different ways to survive and thrive in this new world. At the same time, the plant world was also changing. Flowering plants, or angiosperms, spread across the land, covering Earth in vibrant colours and scents. These plants adapted to a variety of environments and provided food and shelter for the growing numbers of animals. Forests and grasslands expanded, and with them came a rich web of life. The Paleogene was truly a rebirth for the planet's ecosystems. In just a few million years, Earth went from devastation to abundance. Life didn't just bounce back. It flourished in ways that laid the groundwork for much of what we see today. The disappearance of the dinosaurs wasn't the end. It was the beginning of something new. Their extinction opened up countless opportunities for animals that had once lived in their shadow. Birds began to take over the skies. Mammals explored every corner of the land, evolving to fit every possible role, from tiny burrowers to massive grazers. Even more fascinating is how some mammals developed the power of flight, giving rise to bats, while others returned to the sea and evolved into early whales. It was a time of creative evolution, where animals adapted in bold new ways to the challenges and chances of their environment. Plants too took advantage of the quieter world. Without huge dinosaurs to trample or eat them, flowering plants spread even more quickly, transforming landscapes and supporting even more forms of life. From towering forests to open plains, the Earth became a mosaic of habitats, each buzzing with activity. This burst of new life after the dinosaurs' fall didn't just fill the gaps left behind, it changed the entire direction of evolution on Earth. It created new ecological roles and new kinds of animals to fill them, setting the stage for the incredible diversity of life we see today. To truly understand how major leaps in evolution happen, we have to go even further back, to a time known as the Cambrian period, about 500 million years ago. This is when life first exploded in complexity and variety in what scientists call the Cambrian explosion. During this incredible time, many of the basic body plans for animals we know today first appeared. Three groups in particular stood out. Arthropods, like the ancient ancestors of insects, spiders and crabs, developed hard exoskeletons and jointed legs, making them versatile and tough. Today, insects alone number over 1 million described species, a true testament to their evolutionary success. Mollusks, a group that includes clams, snails and octopuses, also rose to prominence. Some grew protective shells, while others, like early cephalopods, developed intelligence and mobility that made them successful hunters. Echinoderms, such as sea stars and sea urchins, developed unusual traits like radial symmetry and a water-based vascular system. They played key roles in the oceans, contributing to the rich marine ecosystems that are still vital today. The Cambrian explosion was one of nature's most amazing experiments. It revealed just how inventive and adaptable life on Earth could be, even in its earlier stages. From the intense heat of the Paleocene-Eocene thermal maximum to the fresh beginnings of the Paleogene period, and even back to the Cambrian explosion, Earth's story is full of moments where life was pushed to its limits and then found a way to grow stronger. These chapters show us that climate change, mass extinctions, and evolutionary bursts are all part of a long unfolding drama. Every crisis opened doors, every setback gave rise to something new, and over hundreds of millions of years, that's how the beautiful, complex web of life that surrounds us today came to be. The recovery of life after the dinosaurs' disappearance happened in stages, showing how natural systems can rebuild and adjust after disastrous events. At first, the period right after saw a world mostly ruled by small mammals, birds, and many kinds of plants that were able to do well in the new conditions. Over many millions of years, these living things changed, took over different roles in nature, and spread out into many new kinds. Amazingly, many of the groups of mammals we know today first appeared during this time, showing not just strength but also how life can adjust to new surroundings with changing conditions. Understanding this past recovery helps us understand the current crisis in life we are facing, mostly because of human actions like the destruction of habitats, pollution, and changes in the climate. The earlier disappearance and later recovery show that while nature can come back, the process is not fast or certain. Each event of loss makes the gene pool smaller and breaks the way nature works, making it harder and harder for life to recover. The slower bounce back after the last big loss compared to earlier ones shows how much we have lost in terms of species and natural places, some of which may never return to how they once were. Also, the history of how life came back shows how everything in nature is connected. The roles that species play in nature mean that losing one can cause a chain reaction, affecting many others. As we move through a world facing huge environmental changes, the lessons of the past remind us how important it is to care for nature and protect the whole environment. Taking care of the web of life is not just about saving single animals or plants, but about making sure that nature stays steady and strong as a whole. All through Earth's past, changes in climate have been a regular part of life, shaping the world and affecting living things on a large scale. When we look at old climate changes like the ice ages or the warm times that followed, we can see clear connections to today. In both past and present, these changes are usually caused by many things, such as volcanoes, changes in sunlight, and shifts in ocean movements. But what makes today different is the big effect of human actions. Today's climate crisis is mostly caused by the buildup of heat-trapping gases in the air, mostly from burning oil, gas and coal, and from cutting down forests. In the past, natural things like shifts in Earth's orbit, called Milankovitch cycles, were the main reasons for climate change. These natural patterns still happen, but the speed and size of today's changes are far greater than anything seen before. This fast-changing climate is something new and brings risks to both nature and people. Looking at the past shows us how life can survive and adjust. During old climate changes, living things either changed to fit the new conditions or they disappeared. Today we face the same problems, but we now have science and tools that help us watch these changes and make plans to deal with them, such as using clean energy and starting projects to protect nature. In the end, comparing past and present climate changes tells a long story of challenges and changes. Learning from this story is important as we deal with today's climate problems. As we think about Earth's past climate, it becomes clear that even though the causes may be different, the need to act and adjust is just as important now as it ever was. Studying life that came after the time of dinosaurs gives scientists valuable clues about how nature reacts to big changes. The disappearance event that wiped out the dinosaurs around 66 million years ago made space for mammals and birds to grow in number, creating a rich mix of life that would later become the many types of nature we see today. By understanding this huge turning point, we can better see how life changes and grows after big disasters. During the time after the dinosaurs, Earth went through big changes in weather, land shapes, and life variety. These changes created new kinds of nature, giving scientists a real-world lab to study. For example, looking at fossils shows how living things change to fit the new conditions, like different temperatures and food sources. This is especially useful now as we face today's climate changes. Learning how past life adjusted can help us guess how today's living things might react to current pressures. Also, the way life came back after the dinosaurs shows how strong nature can be. Places that were once destroyed began to grow back, though in new forms. This strength is important as we see how human actions like cutting forests and polluting the environment are affecting life. By comparing today to the past, scientists can better see which kinds of animals and plants may do well or badly, and which natural places might be more at risk. However, the time after the dinosaurs shows how deeply life and nature are tied together. The loss of powerful species gave others a chance to grow, leading to more types of life. By learning how these changes worked, we can come up with better ways to protect life today. The past teaches us not only about strength and change, but also about our duty to care for and protect the balance of nature on Earth. The lessons from the time after the dinosaurs are both a warning and a sign of hope for the future. Studying past loss events gives us important lessons about strength and the fragile links in nature. Throughout Earth's past, many big disappearances have happened, and each one teaches us how life reacts to huge environmental changes. For example, the Permian Triassic loss, also called the Great Dying, wiped out almost 90% of all life. Learning about what caused these big losses, like volcanoes and climate shifts, shows how life is at risk when the world changes too quickly. One of the most important lessons is the need for life variety. Natural systems with many different types of living things can handle problems better. This variety works like a safety net, letting some species survive when others can't, but human actions like destroying habitats, polluting and changing the climate reduce this variety, putting whole systems in danger. Saving many types of life is not just about protecting single animals or plants, it is about keeping our planet healthy and ready for future problems. Another key lesson is how species are linked. When one kind of animal or plant disappears, it can affect many others. For example, when the passenger pigeon went extinct, it not only hurt the animals that ate it, but also changed the way plants spread, since the bird helped carry seeds. Keeping life variety safe means saving the many connections between species so that nature can stay in balance and work well. When the dinosaurs vanished from the Earth around 66 million years ago, it marked one of the most dramatic turning points in the history of life on our planet. This mass extinction event, possibly triggered by a giant asteroid impact and massive volcanic activity, wiped out nearly 3/4 of all plant and animal species. But from this incredible loss came a new beginning, a chance for life to start fresh. In the millions of years that followed, the Earth underwent a powerful recovery. New species began to appear, ecosystems reorganized themselves, and the stage was set for an explosion of biodiversity. It was during this time that mammals started to rise in prominence, eventually giving rise to the diverse creatures we see today, including ourselves. Birds, which had survived the extinction, also began to evolve into many new forms. The world, once ruled by gigantic reptiles, was now open for smaller, more adaptable animals to take center stage. Thanks to amazing advancements in modern technology, scientists today can study this time period more closely than ever before. One of the most exciting tools they use is computed tomography, or CT scanning. This technology is like taking a three-dimensional X-ray of a fossil, allowing scientists to look inside it without breaking it open. With these detailed images, paleontologists can examine tiny features, like the structure of a bone or the shape of a brain cavity, and learn how ancient creatures moved, hunted, and lived. These scans allow researchers to digitally dissect fossils. That means they can peel back layers virtually and see things that were once completely hidden. This non-destructive method has been a game-changer in understanding how life evolved after the dinosaurs disappeared. It has helped scientists trace the development of early mammals and birds, revealing how they gradually adapted to fill the empty niches left behind by the extinct giants. Another major breakthrough in studying the ancient world comes from new and powerful dating techniques. Knowing exactly when a fossil is from helps scientists place it in the right spot on the timeline of life. Tools like radiocarbon dating and luminescence dating let researchers figure out how old rocks and fossils are with amazing accuracy. These methods help pinpoint key moments in Earth's history, such as when flowering plants first took over landscapes, or when early mammals began spreading into new environments. Luminescence dating, for instance, measures the last time minerals like quartz or feldspar were exposed to sunlight. When these minerals are buried, they begin to collect energy from natural background radiation. Scientists can now measure that energy and determine when the sediment was last exposed, effectively giving them a timestamp on when the fossil was buried. Another powerful method is argon-argon dating, which is especially useful for volcanic rocks. When a volcano erupts, it releases gases, including a form of argon. Over time, radioactive argon slowly changes into a stable form. By comparing the two forms, scientists can determine the age of the volcanic rock, and if fossils are found in the same layers, their age too can be estimated with precision. There is also paleomagnetic dating, which works in a fascinating way. As sediment layers form, tiny magnetic minerals inside them align with the Earth's magnetic field. Since Earth's magnetic field has flipped many times throughout history, scientists can use these changes as time markers. By matching the magnetic pattern in a sediment layer with known reversals, they can estimate the age of the fossils inside. All of these dating methods, when used together, provide a multi-layered approach that brings incredible clarity to the story of life after the dinosaurs. Beyond dating, researchers also use genomic analysis and ancient DNA technology to dig even deeper into the past. These tools allow scientists to extract and study the genetic material from ancient organisms. By comparing these genes to modern species, scientists can build family trees and understand how life evolved in response to the new post-dinosaur world. It reveals how animals adapted to changing climates, new habitats, and different food sources, offering a genetic map of survival and innovation. But the discoveries don't stop there. Paleontologists also use many clever methods to figure out what the world looked like millions of years ago. By studying fossilized plants, they can tell what kind of climate existed at different times. For example, broad, smooth leaves often belong to plants that grow in warm, wet areas, while narrow, jagged leaves suggest colder or drier environments. These plant clues help scientists reconstruct ancient forests, swamps, and grasslands. In addition, scientists collect sediment cores from the bottom of lakes and oceans. These long cylinders of mud and sand hold layer after layer of history. Inside them are tiny fossils, pollen grains, and chemical signatures that reveal temperature changes, rainfall patterns, and even the presence of wildfires. Another key tool is the study of isotopes, special versions of elements like oxygen and carbon. These isotopes behave differently depending on the climate. For instance, warmer temperatures cause oxygen isotopes in ice and shell fossils to shift in a measurable way. By analysing these isotopes, scientists can determine whether the planet was going through a hot spell, an ice age, or something in between. Thanks to these discoveries, we now have a clearer picture of how life bounced back after the fall of the dinosaurs. The Earth did not remain a desolate place for long. Instead, it became a cradle of innovation. New species emerged, ecosystems evolved, and a once reptile-dominated planet slowly transformed into a world ruled by mammals, birds, and flowering plants. Modern tools, like X-ray fluorescence and infrared spectroscopy, further enrich this picture. These methods help analyze the chemistry of fossils and the sediments they're found in. They tell us what the ancient creatures ate, how they moved, and even what kind of environments they lived in. Digital modelling is yet another powerful addition. Scientists can now simulate entire ancient ecosystems on computers. These digital reconstructions let researchers test ideas about how species interacted, how food chains worked, and how climate changes affected life over time. They've even helped shed light on the early part of the Cenozoic era, the period that began after the dinosaurs vanished. During this time, the Earth's climate shifted rapidly, and species had to evolve quickly to survive. Altogether, these tools have given us a window into a lost world. They've helped scientists tell the remarkable story of how life recovered, adapted, and flourished after one of the most devastating mass extinctions in history. Each fossil, each rock layer, and each DNA strand helps us understand how the web of life rewove itself over tens of millions of years. After the dinosaurs disappeared from the Earth about 66 million years ago, the planet went through one of the most dramatic changes in its entire history. The sudden absence of these enormous creatures left behind countless empty spaces, both physical and ecological, that needed to be filled. Into this new world stepped the mammals, ready to explore and take over roles that had once belonged to the giant reptiles. As mammals spread across the planet, they began to settle into all sorts of environments, from dense forests and grassy plains to rocky mountains and underground burrows. This great expansion brought them into contact with plants that were also changing in response to the loss of large herbivores. With no more dinosaurs to trample and feast on them, many plants, especially flowering ones, found the perfect opportunity to grow, spread and evolve in new ways. Insects, especially bees, beetles, butterflies and ants, played a huge part in this transformation. These tiny creatures helped flowering plants by carrying pollen from one blossom to another, allowing new plant species to grow and multiply. In return, the flowers provided nectar, a sweet food source which made this relationship beneficial for both sides. This back-and-forth exchange created a mutual bond, what scientists call a mutualistic relationship, where both the plants and the insects depended on each other to survive and thrive. Soon, herbivorous mammals, those that eat plants, joined this circle of life. They fed on the rich variety of leaves, fruits, and seeds that flowering plants offered. Some plants even began to evolve fruits and seed pods, specially designed to be eaten and carried by animals. As mammals moved around and dropped seeds far from where they had eaten the fruits, they unknowingly helped plants spread across wide areas. This was the beginning of a deep and lasting partnership between animals and plants. But it wasn't just about eating and being eaten. Mammals were also changing their surroundings. Their feeding habits affected how plants grew, how forests spread, and even how certain types of trees and grasses became more common. In turn, the changing landscapes pushed mammals to keep evolving, learning to survive in new habitats. All of this created a lively and complex web of life, where each species influenced others and helped shape the environment. This remarkable period, which followed the end of the dinosaurs, gave rise to the Cenozoic era, known as the Age of Mammals. During this time, life exploded in variety. With the dinosaurs gone, mammals faced fewer predators and less competition. That freedom allowed them to grow in size, take on new forms, and adapt to all sorts of lifestyles. Some mammals began swinging through treetops, while others dug tunnels underground or ran freely across open grasslands. Each species competed for food, shelter, and mates, and this competition helped drive evolution forward. Birds also took advantage of the new world. As descendants of certain dinosaur groups, they had already begun to fly, but after the mass extinction, birds evolved rapidly into many different shapes and sizes. Some became powerful hunters soaring through the skies, while others adapted to walk or hop on the ground, pecking for seeds or insects. Their ability to fill different roles in nature helped create the amazing diversity of bird species we see today. As species adapted and competed, ecosystems became more diverse and more complex. The world was no longer just about survival. It was about thriving, transforming, and creating new ways to live. This explosive growth of life showed how powerful nature's drive for adaptation truly is. At the same time, the Earth saw the rise of special relationships between different species, called symbiotic relationships. These partnerships came in different forms. Some were mutually beneficial, like bees and flowers. Others were neutral for one partner but helpful for the other, a situation called commensalism. And some were one-sided in a harmful way, like parasitism, where one species benefits while the other suffers. A perfect example of mutualism is the relationship between flowering plants and pollinators. Bees, butterflies and other insects collect nectar for food, but while doing so, they carry pollen between flowers, helping plants reproduce. Both sides gain something, and neither can easily survive without the other. In the oceans, tiny algae called zooxanthellae live inside coral reefs, and produce food through photosynthesis. In return, the corals give the algae a safe place to live and access to sunlight. This teamwork supports the entire coral reef ecosystem, which is home to thousands of marine species. Parasitism, although more damaging, is also important in nature. Take tapeworms, for example. These parasites live inside the intestines of animals and absorb nutrients from their hosts, often causing weakness or disease. While it may sound cruel, such relationships help control population sizes and encourage hosts to develop new defenses, pushing evolution forward. Over time, species continued to shape their surroundings and respond to changes in climate, geography, and other environmental factors. When conditions changed, such as shifts in rainfall or temperature, some species moved to new areas, while others adapted to survive. These changes often led to new traits and behaviours. One famous example is the Galapagos finches, which evolved different beak shapes and feeding habits based on the food available on each island. Nature also rebuilds itself after disasters. When a forest burns down or a volcano erupts, the land is first colonised by fast-growing plants. Then come shrubs, trees, and animals, and over time a whole new ecosystem takes shape. This process, known as ecological succession, shows how life can bounce back and even flourish after being disrupted. All these interactions between species and their environments, between plants and animals, between survival and competition, have shaped the living world as we know it. From the fall of the dinosaurs to the rise of mammals, from the buzzing of bees to the deep roots of ancient forests, nature's story is one of endless change, connection, and creativity. It reminds us that even after great loss, life finds a way not just to return, but to become something entirely new. After the mighty reign of the dinosaurs came to a sudden and dramatic end around 66 million years ago, the world was never the same. A great extinction event swept the planet, likely caused by a colossal asteroid impact and intense volcanic activity. With the disappearance of these towering giants, the Earth's ecosystems were left wide open. Many living creatures vanished, but some survived, and those survivors had the chance to reshape the future of life. Among the creatures that weathered this catastrophe were reptiles. Though the age of the dinosaurs was over, their reptilian cousins stepped into the spotlight. Suddenly, countless ecological spaces were empty. There were no longer massive herbivores eating plants or fearsome predators dominating the land. This gave the remaining reptiles the opportunity to spread out, adapt, and thrive in ways that had never been possible before. One of the most fascinating examples of this reptilian rebirth came from the turtles. Some of these ancient turtles evolved tough protective shells that worked like a personal fortress. These shells helped them escape danger, especially by letting them retreat into rivers, lakes, and oceans. Once in the water, turtles became excellent swimmers. This move from land to water gave them safety from land predators and allowed them to explore all kinds of watery homes. Over time, turtles branched out into many different species, each uniquely shaped by the environment it lived in. Some lived in muddy ponds, some in fast-flowing rivers, and others in salty seas, all thanks to their incredible ability to adapt. Lizards and snakes also rose to prominence during this time. Lizards began to evolve in many different directions, developing clever ways to survive. Some grew special skin colours and patterns that helped them blend in with rocks, trees, and leaves. This camouflage made it harder for predators to spot them, and it made it easier for them to sneak up on prey. Snakes, who had lizard-like ancestors, took an even more dramatic turn. They gradually lost their limbs and developed long, flexible bodies. This gave them the ability to slither through thick grass, slip into tiny holes, and even swim in water. As a result, snakes could hunt in many more places than before and became skilled predators in their own right. As millions of years passed, the Earth's climate began to warm, and reptiles took full advantage. They spread across deserts, jungles, swamps, and forests, becoming one of the most diverse and successful groups of animals on the planet. What started as survival turned into a story of triumph. Reptiles not only survived, they flourished, showing the world how powerful adaptation and resilience could be. At the same time, amphibians were also undergoing an amazing transformation. These creatures, Frogs, toads, salamanders, and others had already been around for a long time, but the Great Extinction, which happened around 65 to 66 million years ago, gave them new chances to grow and evolve. With many of their predators and competitors now gone, amphibians began to move into new habitats that were once off limits. Forests, wetlands, and even dry lands became homes for these versatile animals. They developed into many different species, each with its own size, shape, colour, and behaviour. Frogs with bright colours, toads with warty skin, salamanders that glowed in the dark. Nature experimented in every way imaginable. This explosion of diversity helped amphibians survive in all kinds of environments, from mountain streams to tropical rainforests. But the changes weren't only on the outside. Amphibians also began to change the way they reproduced and raised their young. Instead of laying eggs only in still, shallow water, which could easily dry up or be disturbed, some species began laying eggs on land or in tiny puddles that only lasted a short time. Some even skipped the tadpole stage entirely, hatching as mini adults ready to explore. These new breeding strategies made them more flexible and better suited to life in a changing world. Amphibians also started to communicate more with each other. Frogs and toads, in particular, developed loud calls to attract mates. These songs echoed through the night during breeding seasons, becoming an important part of how these animals found partners and warned off rivals. Their social behaviour grew more complex, and their role in the ecosystem became more important. From keeping insect populations in check to becoming food for larger animals, amphibians found their place in the new post-dinosaur world, and they held on to it. Beneath the waves, dramatic changes were also unfolding. After the extinction of the dinosaurs, marine ecosystems were thrown into chaos. But once again, life bounced back, and fish were quick to take advantage. With fewer predators and less competition, fish populations began to grow and diversify like never before. One of the biggest winners in this watery revolution was a group called the bony fish. Unlike sharks and rays, which have skeletons made of cartilage, these fish had strong, bony skeletons that gave them support and flexibility. They came in every size, shape, and colour. Some became swift hunters, with sharp teeth and lightning speed. Others developed ways to feed on tiny floating creatures or scrape algae off rocks. Over time, fish developed clever tricks to stay safe and succeed. Some wore the colours of the ocean floor, blending in with sand and coral. Others sparkled with bright, eye-catching patterns to confuse predators or attract mates. Their fins changed too. Some became like wings for gliding through water, while others gave them the power to make tight turns or stay perfectly still. Thanks to these changes, fish didn't just recover, they exploded in number and variety. The oceans became rich with life, from the colourful coral reefs to the deepest, darkest trenches. This underwater renaissance shows how nature can heal and thrive after even the greatest disasters. Above the waves, another story was taking flight. Literally. Birds, the living descendants of small feathered dinosaurs, had already begun to evolve before the extinction. But with the dinosaurs gone, birds had a chance to expand into every corner of the world. Some birds grew large, losing the ability to fly altogether. Birds like ostriches, emus, and kiwis developed strong legs and heavy bodies, perfect for running across open land. In places where predators were rare or absent, there was no need to fly. These birds became fast runners and expert foragers, using their size and strength to their advantage. Flightless birds didn't lose out, they just found different ways to live. Their powerful legs helped them escape danger, and their beaks and eyes adapted to find food in their new environments. They even came up with smart ways to raise their young, often using nests on the ground and fierce protection strategies. Meanwhile, other birds continued to fly high and far, adapting to forests, mountains, deserts, and coasts. Their feathers, beaks, and songs changed depending on where they lived and what they needed to survive. The bird world became one of the most diverse and colourful branches of the tree of life. Even today, scientists study these bird species, especially the big, flightless ones, to understand how animals might keep adapting in a world that's always changing. As climates shift and new challenges arise, birds continue to show us how life can evolve in amazing ways. In the grand story of life after the dinosaurs, reptiles, amphibians, fish, and birds each wrote their own chapters full of survival, transformation, and triumph. Their journeys remind us that even after the darkest times, life finds a way not just to survive, but to flourish in new and unexpected directions. After the mighty reign of the dinosaurs came to a sudden and dramatic end around Earth did not simply settle into peace. Instead, it went through a series of powerful events that caused enormous changes in life on the planet. These events, known as mass extinction events, wiped out huge numbers of species, but they also opened the door for new forms of life to rise and take over. One of the most remarkable of these events happened about 55 million years ago. Scientists call it the Paleocene-Eocene thermal maximum, or PETM for short. During this time, Earth experienced a rapid and intense warming of the climate. Temperatures rose quickly, most likely because of large volcanic eruptions and the release of massive amounts of greenhouse gases such as carbon dioxide and methane into the air. These changes made life difficult for many species, especially those living in the oceans. Many creatures simply could not survive the rising heat and changes in their environment, leading to widespread disappearances of marine life. If we look much farther back in time, we come to the end of the Permian period, around 252 million years ago. This was the time of the Great Dying, the most devastating extinction event in Earth's history. It wiped out an estimated 97% of marine life and around 70% of land animals and plants. The exact cause of this catastrophe is still debated, but many scientists believe it was linked to enormous volcanic eruptions in what is now Siberia, along with rapid climate change and changes in ocean chemistry. This event happened before the age of the dinosaurs, but it deeply affected the future of evolution by clearing the stage for new life to emerge. Another major extinction, perhaps the most famous of all, happened at the end of the Cretaceous period, around 66 million years ago. This event is often called the Cretaceous-Paleogene extinction, or KPG event. It led to the vanishing of about 3/4 of all life on Earth, including all the non-bird dinosaurs. Many scientists believe a huge asteroid slammed into Earth, triggering fires, darkness, and a dramatic drop in temperature. This global disaster gave mammals, small and relatively unimportant at the time, a chance to rise and fill the empty spaces left behind. Over millions of years, they grew in size and number, eventually giving rise to the amazing variety of mammals we see today, including us humans. More recently, about 12,000 years ago, Earth went through what is known as the Quaternary extinction event. This happened during the last ice age and saw the disappearance of many giant mammals such as the woolly mammoth, the saber-toothed cat, and the giant ground sloth. The cause was likely a mix of rapid climate changes as the ice age ended, and hunting by humans who were spreading across the globe at that time. This extinction changed entire ecosystems, especially in North and South America, and reminds us that even our ancestors had a powerful effect on nature. But mass extinctions were not the only events that shaped the story of life. One of the most important breakthroughs happened around 3 billion years ago, when simple organisms discovered how to use sunlight to make energy through a process called photosynthesis. This process also produced oxygen, which slowly began to fill the atmosphere. That oxygen eventually made it possible for more complex life, like animals, to evolve. This great transformation is known as the Great Oxygenation Event, and it changed the planet forever. Continents also played a major role in this story. Over hundreds of millions of years, the massive land masses of Earth have slowly moved, crashing into each other and drifting apart. This ongoing movement, called continental drift, shaped oceans, mountains, and climates. It also separated groups of animals and plants, allowing them to evolve in different ways. For example, the animals in Australia are unlike any found elsewhere, because that continent has been isolated for tens of millions of years. Another key moment was the Permian-Triassic extinction, which happened about 250 million years ago. This is the same event often called the Great Dying, a terrible time when around 90% of ocean creatures and 3/4 of land species vanished. After this mass extinction, life slowly recovered. But what followed was an explosion of new forms and new adaptations. Reptiles became dominant, and this led eventually to the rise of the dinosaurs. Natural disasters like asteroid strikes have also had a huge impact. The asteroid that hit Earth 66 million years ago is believed to have caused massive wildfires, darkness from dust clouds, acid rain, and a sudden collapse of ecosystems. That disaster wiped out the dinosaurs, but it gave mammals a chance to become Earth's leading life forms, and millions of years later, humans appeared. All these extinction events, while tragic, have also shown us something amazing. Life on Earth is incredibly resilient. After each major loss, nature finds a way to bounce back, evolve, and fill the empty spaces. The species that survive mass extinctions often adapt quickly, taking advantage of the new opportunities. This process is called evolutionary radiation, and it is how many new forms of life come into being after a disaster. For example, when the dinosaurs disappeared, mammals that had once lived in the shadows quickly spread into new environments. Some became tiny rodents. Others grew into giant elephants, fast cheetahs, or clever primates. Over time, these changes led to the rich diversity of mammals that we see today. Even though evolution is usually slow and steady, these moments of crisis speed things up. They show us that change, sometimes very sudden and harsh, can be a powerful force in nature. By studying the past, scientists have learned that extinction is not just about loss. It is also about renewal, adaptation, and survival. It teaches us how life is connected, how ecosystems depend on balance, and how the disappearance of one species can affect many others. For scientists, dinosaurs have become more than just ancient animals. They are now powerful symbols of how life changes over time and how entire species can vanish from existence. The mystery of their disappearance has sparked centuries of curiosity and helped shape the field of paleontology, the study of ancient life. Dinosaurs opened the door to important discoveries about evolution, extinction, and the long and often dramatic history of life on our planet. But dinosaurs didn't just make their mark in science, they also became legends in our culture. For generations, people have been fascinated by the idea of these enormous creatures that once walked the earth. They appear in paintings, books, stories, and especially in movies. A perfect example is the famous film Jurassic Park, which didn't just entertain millions. It also helped bring scientific topics like genetics, evolution, and extinct species into everyday conversations. These films and books invite people to think deeply about survival, change, and the sometimes fragile relationship between humans and nature. Studying dinosaurs also teaches us lessons about how Earth's environment has changed through time and how life manages to survive those changes. By understanding what led to their extinction, whether it was the asteroid, massive volcanic eruptions, changes in the climate, or a mix of all three, scientists can draw comparisons to today's world. Right now, our planet is facing serious challenges, like climate change and the loss of many animal and plant species. Looking back at what happened to the dinosaurs reminds us how delicate the balance of life can be and how important it is to protect the world we live in today. The legacy of the dinosaurs goes far beyond the fossil record. Their story continues to fuel both our curiosity and creativity. As we uncover more about their lives and their vanishing, we also learn more about how ecosystems work, how species evolve, and what might lie ahead for life on Earth, including for us humans. Their bones may be buried in stone, but their story lives on in museums, classrooms, movies, and even in our dreams. Long before science gave us a clear understanding of what dinosaurs were, people had been finding their fossilized remains and making up stories to explain them. In many ancient cultures, these massive bones were thought to belong to mythical creatures or even gods. Among Native American tribes in North America, some believed that large bones found in the ground belonged to enormous beasts that roamed the earth before humans. These ancient bones were sometimes used to explain how the land was formed or how mountains came to be. In Asia, especially in China, people also discovered huge fossil bones and interpreted them through the lens of mythology. Some Chinese legends describe these bones as the remains of dragons, mighty beings thought to represent power, wisdom, and mystery. It is easy to see why this link was made. Dinosaurs and dragons share similar shapes and features. In many cultures around the world, these ancient remains were not seen as dead things from the past. but as living symbols within stories and traditions that gave meaning to the world. This fascination led to rich storytelling that often tried to explain why these giant creatures vanished. Many myths told of gods who grew angry and punished the earth with floods, fire, or storms. Others told of great battles between creatures or divine beings ending in destruction. These stories reflect a deep human need to make sense of events beyond our control, especially when it comes to death, change, and disappearance. Even though they are based on ancient beliefs, these tales often mirror the concerns we still have today about our future and the health of our planet. In more recent times, dinosaurs have made a dramatic return, this time in popular culture. They are no longer just bones in the ground or mythical beasts in old legends. Through movies, books, and television, they have become vivid characters brought back to life through animation and imagination. Some stories imagine a world where dinosaurs return or where their DNA can be used to bring them back. These modern myths blend science and fiction, keeping the mystery alive and reminding us how much we still wonder about the past and the future. How the public sees the extinction of the dinosaurs has been shaped largely by how this story is told in media. Films, documentaries, and children's books often focus on a single dramatic explanation, like a huge asteroid crashing into Earth and wiping everything out. These stories are exciting and easy to understand, especially for younger audiences. They show sudden destruction, fire, darkness, chaos, and create a lasting image of how these magnificent creatures vanished from the Earth. But these thrilling tales don't always tell the full truth. While there is strong scientific evidence that an asteroid hit the Earth about 66 million years ago, researchers now believe it was not the only cause. Other factors, like rising temperatures, volcanic eruptions, and changes in sea levels, also played a part. The world was already unstable, and the asteroid may have been the final blow. However, media stories often leave these details out because they are more complicated and less dramatic. Another common issue is that many documentaries and movies focus only on the end of the dinosaurs, not on how they lived. This can make people think that dinosaurs were just giant monsters that ruled the world until disaster struck. In reality, they were a very diverse group with thousands of species that lived in different environments, developed unique features, and filled many ecological roles. Focusing only on famous ones like Tyrannosaurus rex creates a narrow picture that leaves out the incredible variety of dinosaur life. Even so, the media has helped spark interest in dinosaurs for millions of people. The challenge now is to use that interest to teach the deeper truths, how life changes, adapts, and sometimes disappears. When people start asking questions and thinking critically about what they see in movies and read in books, they gain a better understanding of Earth's history and the patterns of life and extinction that have shaped it. Fossil discoveries are like time machines that connect us to a world that existed long before us. Every time a paleontologist uncovers the remains of an ancient animal or plant, it opens a new window into the story of life on Earth. These fossils reveal how creatures lived, how they adapted to changing environments, and how they sometimes failed to survive those changes. The search for fossils fuels excitement and wonder, because every new find has the power to change what we thought we knew. Finding a fossil is a thrilling experience, not just for scientists but for anyone who loves to explore the past. Whether it's a huge dinosaur skeleton pulled from deep within rock or the delicate impression of a fern leaf, each one tells a story. Museums all over the world bring these ancient treasures to the public. Children and adults stand in front of giant bones with wide eyes, imagining a world full of roaring giants and strange landscapes. Sometimes, fossils surprise even the experts. A new species might be discovered, or an old theory might be challenged. In these moments, science shows how it is always evolving. Paleontology is not about memorizing facts. It's about asking questions, testing ideas, and rewriting the story when new evidence is found. This constant discovery keeps the field alive and exciting. These ancient remains don't just stay in museums, they also live on in stories, films, and games. They inspire new generations to dream about the past and think about the future. As we face serious questions about our planet's health, biodiversity, and survival, the fossils of the past remind us what's at stake. They teach us that change is constant, life is resilient but also fragile, and that our curiosity may be the key to understanding and protecting the world around us. Back in the Cretaceous days, the planet was warm and lush. The Earth was like a giant greenhouse, with high levels of carbon dioxide keeping temperatures comfortably warm almost everywhere. Vast forests and rich plant life covered the continents, and the oceans teemed with a colourful mix of marine creatures, including huge swimming reptiles. Dinosaurs, in all their mighty and mysterious forms, roamed freely across wide subtropical regions filled with life. But this warm and thriving world came to a sudden and catastrophic halt. A massive asteroid, larger than Mount Everest, slammed into what is now the Yucatan Peninsula in Mexico. The explosion released more energy than millions of atomic bombs combined. It carved out a huge crater, launched molten rock and dust into the atmosphere, and sparked raging wildfires, monstrous tsunamis, and storms unlike anything we can imagine. The most terrifying part. The skies went dark. A thick cloud of ash, dust, and soot blocked the sunlight, plunging the Earth into what scientists call a nuclear winter. With sunlight cut off, temperatures dropped fast. Plants withered, food chains collapsed, and just like that, about 3/4 of all living species, including the dinosaurs, vanished from the face of the Earth. But from this destruction came new beginnings. As the dust slowly settled over thousands of years, Earth began to recover, but it was not the same world anymore. The Paleogene period, which lasted from around 66 million to 23 million years ago, brought cooler temperatures and a more temperate climate. Thick tropical jungles gradually gave way to forests, grasslands, and open spaces. The age of the dinosaurs had ended, and a new era, the age of mammals, was about to begin. In the early days of the Paleogene, during a time known as the Paleocene-Epoch, the climate remained warm and fairly stable. Even regions close to the poles enjoyed subtropical weather. Forests spread far and wide, and ecosystems began to bounce back with an explosion of new life. Birds became more diverse, and mammals started to evolve in amazing ways. Without dinosaurs around, mammals began to explore different roles in the ecosystem. Some became grazers, some became hunters, and others adapted to life in trees, water, or underground. As the Paleocene gave way to the Eocene epoch, global temperatures climbed even higher. Forests flourished, covering much of the planet. Strange new mammals appeared, some with long limbs, others with large brains, and they explored every corner of this warming world. But eventually the climate took another turn. During the later part of the Eocene, things began to cool again. One of the biggest reasons for this change was the rise of the Himalayan mountains, which disrupted wind and ocean patterns and changed how heat moved around the globe. This cooling trend led to the birth of the first polar ice sheets in Antarctica, marking the beginning of Earth's long journey into ice ages and seasonal climate swings. By the time the Oligocene epoch arrived, Earth had entered a much cooler and drier phase. Forests began to shrink and open grasslands spread. Mammals adapted to these changes. Some became fast runners to survive in wide, open spaces, while others grew larger to protect themselves from predators. The climate continued to shift toward what we now recognize as modern weather patterns, with cooler winters, drier regions, and even hints of future ice ages. Meanwhile, greenhouse gases like carbon dioxide and methane started to play a bigger role in shaping the planet's climate. These gases built up in the atmosphere, trapping heat and causing the Earth to warm again in cycles. With each fluctuation in temperature, whether cooling or warming, plants and animals had to adapt quickly or face extinction. During warmer times, lush vegetation returned, attracting insects, birds, and mammals. New plants with flowers and fruits spread rapidly, often with help from pollinating insects like bees and butterflies. Mammals that fed on these plants, or hunted those that did, evolved right alongside them. New kinds of predators and prey emerged, and ecosystems grew more complex. As grasslands spread across the Earth, animals evolved to match. Large herbivores like ancient horses and rhinoceroses grazed the plains, and in response, swift and clever predators evolved to chase them. Meanwhile, birds filled the skies with new songs and colours, and flowering plants filled the air with scents that attracted both animals and insects. Plants themselves had to adjust to climate changes too. Some grew deeper roots to reach underground water during dry times. Others changed their blooming times to match shifting seasons. When their native habitats became too hot or too cold, many plants migrated, spreading their seeds farther north, south, or higher up into the mountains. All these changes, from giant asteroid impacts to drifting continents, shifting climates, and the rise of greenhouse gases, reshaped life on Earth again and again. Every plant, every animal, and every ecosystem had to respond to these changes or disappear. Those that could not adapt vanished forever. Those that could evolved into something new, something better suited to the changing world. And so, the Paleogene stands out as one of the most important chapters in Earth's story. It was a time of incredible change, where destruction gave way to rebirth, and where the seeds of the modern world were planted. It reminds us just how powerful nature is, and how closely all life on Earth is tied to the ever-changing climate around us. The time after the dinosaurs, known as the Cenozoic era, was not one of peace and stillness. The Earth's climate kept changing. In the earlier parts of this era, the planet was much warmer than it is now. Thick forests covered vast areas, and animal life was incredibly rich. But as time went on, things started to cool down. The air became drier, and great forests gave way to open grasslands and wide savannas. This shifting climate changed everything. Animals that once hid in forests had to learn to survive in open spaces. Mammals like horses and antelope evolved strong legs to run from predators across the grasslands. Elephants developed long trunks to help them find food and water. Plants too changed, growing shorter and tougher to survive the drier conditions. While forests and grasslands grew on land, wetlands and coastlines also began to flourish. These watery habitats became home to all kinds of life: frogs, turtles, water birds, and early versions of crocodiles. Meanwhile, in the oceans, life was also changing. Before the dinosaurs disappeared, the seas had been full of giant marine reptiles, strange shelled creatures called ammonites, and coral reefs that stretched for miles. But the asteroid impact and the environmental chaos that followed hit the oceans hard. Many species went extinct, especially the ammonites and some corals. The food chains were thrown into confusion. However, just like on land, new life began to rise from the ruins. Bony fish became more diverse, and sharks, rays, and other sea creatures began to thrive again. Slower-growing, hardy coral species rebuilt the reefs, and new marine ecosystems came to life. As millions and millions of years passed, all these changes shaped the Earth into something entirely new. Mammals grew more diverse and intelligent. Birds filled the skies with song. Insects and flowering plants formed tight bonds. Oceans, wetlands, grasslands, and forests became homes to countless forms of life, each one connected to the other in delicate and beautiful ways. What began as a moment of devastation, the end of the dinosaurs, had given birth to an explosion of new life. From the ashes of one world, another had risen, full of colour, movement, and complexity. The rich and varied ecosystems we see today, from the African savannas to the Amazon rainforest, are the living result of this long journey of change and survival. Nature, it seems, always finds a way to grow again, even after the darkest times. One of the most exciting chapters in this story began during a time called the Paleogene period, which followed the fall of the dinosaurs. During this era, the ancestors of today's carnivorous mammals, like cats, dogs, bears, and even weasels, started to appear. These early hunters learned to thrive in ecosystems once ruled by dinosaurs. With no more giant predators around to eat them or compete for food, mammals not only grew bigger, but also more diverse in their lifestyles and hunting skills. Among the most famous examples of these new hunters are the ancient ancestors of modern cats and dogs. Over millions of years, some of these creatures developed powerful bodies, sharp senses, and complex strategies to chase and capture their prey. At first, they hunted small animals, but later evolved into larger forms capable of taking down much bigger creatures. This amazing transformation shows just how adaptable and clever life on Earth can be when faced with new challenges. This great shift in power from dinosaurs to mammals changed the course of life forever. It allowed mammals to rise to the top of the food chain, creating entirely new food webs and relationships among species. Fierce new predators emerged to rule forests, plains, and oceans, setting the stage for the complex and beautiful ecosystems we see today. In many ways, The echoes of that ancient extinction are still felt as life continues to grow, shift, and adapt to new conditions. As these new predators took their place at the top, they helped shape the balance of nature. Known as apex predators, these animals sit at the very top of the food web with no natural enemies. They often develop amazing features that help them rule their environment, whether it's strength, speed, sharp senses, or clever hunting skills. For example, the great white shark, one of the ocean's top hunters today, has incredibly sharp eyesight and a powerful sense of smell that lets it detect prey from far away. On land, animals like wolves have strong muscles and incredible agility, but even more important is how they hunt together in groups. By working as a team, they can take down prey that is much larger than any single wolf. Some predators are not just strong, they're also incredibly smart. Orcas, also called killer whales, are a perfect example. These marine predators use teamwork and planning to catch their food. One amazing strategy they use is creating waves to knock seals off floating ice, making them easier to catch. This mix of brain power and cooperation keeps orcas firmly at the top of the ocean food chain. When a new top predator enters an ecosystem, it can affect everything below it. This is called a trophic cascade. For instance, if a predator eats too many herbivores, the number of plant eaters goes down, and as a result, plants and trees may grow back more easily. This chain reaction helps ecosystems stay healthy and full of life, showing how every creature, big or small, plays a role in nature's balance. Looking back at Earth's long history, predator-prey relationships have always been changing and evolving. During the age of the dinosaurs, powerful meat-eaters like Tyrannosaurus rex were at the top. But when these giants disappeared 66 million years ago, the door opened for smaller, quicker, and smarter animals, like mammals and birds, to step into those roles. Freed from the danger of giant dinosaurs, early mammals had more space and time to develop new survival skills. Some grew bigger to protect themselves, others became faster or developed sharp senses to spot danger. As these new herbivores filled the land, new small predators evolved too. These early hunters adapted to prey on the new plant eaters, starting a whole new cycle of predator-prey relationships. As time went on, the strategies used by both hunters and prey became more advanced. Small carnivores like weasels and early wildcats began to appear, pushing their prey to get faster, sneakier, or tougher. It was like an endless arms race. Predators kept improving their hunting skills, while prey animals kept finding better ways to escape. This constant back and forth shaped the animal world we see today. One of the most famous groups of ancient hunters were the saber-toothed mammals. These creatures, including the well-known Smilodon, lived during a time called the Pleistocene epoch, which lasted from about 2.5 million years ago to around 10,000 years ago. They had long, curved teeth that could grab and hold struggling prey. Even though they are often called saber-toothed cats, they weren't true cats like lions or tigers. They belonged to a different branch of the evolutionary tree, showing how many different paths evolution can take. These predators lived during a time when giant herbivores like mammoths and giant ground sloths roamed the earth. As the climate grew colder, many herbivores evolved larger sizes, and the saber-toothed predators adapted to match them. Their strong bodies and muscular arms helped them wrestle large animals to the ground, proving how evolution fine-tunes each species to fit its environment. But saber-toothed cats weren't the only big hunters of their time. Dire wolves and short-faced bears were also dominant predators. Dire wolves lived and hunted in packs, which made them incredibly effective hunters. The short-faced bears, which were much larger than any bears alive today, used a mix of scavenging and hunting to survive. Each species found its own way to thrive, using strength, teamwork, or cleverness to rule their world. However, most of these ancient predators disappeared around 10,000 years ago, likely due to a mix of changing climates and the arrival of early humans. Their story reminds us that evolution never stops. Species rise and fall, adapt or vanish, depending on how well they can survive the ever-changing world around them. After the devastating event that changed life on Earth, life in the oceans was shaken to its core. In the oceans, something truly amazing happened after the disaster. As the skies cleared and the Earth slowly healed, a whole new chapter of marine life began to unfold. With the disappearance of giant predators like mosasaurs and ichthyosaurs, fearsome reptiles that once ruled the seas, new spaces opened up in the food chain. These gaps were quickly filled by smaller creatures that had once lived in fear. Without their predators, they were free to grow, evolve, and take on new forms. Bony fish, for example, began to thrive. They spread out into different environments, developing into countless new species, each perfectly suited for life in coral reefs, open oceans, or coastal shallows. With fewer dangers around, many other forms of marine life, such as the ancient relatives of modern mammals, started exploring new evolutionary paths, slowly transforming into the sea mammals we know today. Over millions of years, shallow coastal areas became home to rich underwater communities. Coral reefs, which had been damaged during the extinction event, slowly grew back. These reefs turned into colourful underwater cities, offering shelter and food to countless marine species. Creatures like mollusks and sea urchins also made a big comeback. By feeding on algae, they helped keep the ecosystem balanced, giving coral and other marine plants a chance to flourish once again. This slow but powerful recovery gave birth to the incredible variety of ocean life we see today. From the first marine mammals to the enormous range of fish and sea creatures now swimming through the oceans, life in the sea proved just how adaptable and resilient it can be. The story of this recovery reminds us how life is connected in delicate ways, and how even after great destruction, nature finds ways to rebuild and grow stronger. Fast forward to the present, and our oceans are facing serious new challenges, this time caused by human activity and climate change. One of the biggest problems is rising ocean temperatures. Just like land animals, sea creatures need certain temperatures to stay healthy. When the water gets too warm, it can change how fish and marine mammals reproduce, migrate, or even survive. Some species struggle to find food or shelter in their usual habitats and may disappear altogether if they can't adapt quickly enough. Another growing threat is something called ocean acidification. As humans release more carbon dioxide into the atmosphere, much of it ends up in the oceans. This makes the water more acidic, which is bad news for creatures like corals, clams, oysters, and even some tiny plankton. These animals build their shells and skeletons using a mineral called calcium carbonate, but in acidic water, it becomes much harder to do so. If these creatures struggle to survive, the entire food web built around them starts to collapse. Climate change is also affecting ocean currents and salinity, or the saltiness of the water. These changes disturb the natural flow of nutrients that many species depend on. Some animals follow specific ocean currents for migration or feeding, and when those patterns shift, they can get lost or arrive too early or late to find food. This creates chaos in the relationships between predators and prey, making it harder for many species to survive. Still, not all is lost. Many marine animals are beginning to show signs of resilience. Some fish are already changing their behaviours or adapting their bodies to cope with warmer temperatures. Scientists are closely studying these changes to understand how life might survive in a hotter, more acidic world. It is a powerful reminder that nature is full of surprises, but also that the balance of life in the ocean is delicate and needs protection. Coral reefs are often called the rainforests of the sea, and for good reason. They're bursting with life and colour, home to thousands of species, and have been around for a very, very long time. Their story began during the Triassic period, roughly 240 million years ago. Back then, Earth was going through major changes. Sea levels rose and fell, and the climate shifted, setting the stage for the first reef-building corals to appear. Over time, different kinds of coral adapted to life in the warm, shallow waters near the equator. One of the most important developments was their partnership with tiny algae called zooxanthellae. These microscopic organisms live inside coral tissues and use sunlight to create energy through photosynthesis. They share that energy with the coral, helping it grow faster and build large reef structures that offer shelter and food to all kinds of marine animals. Like all life on Earth, coral reefs have faced many hardships. They were affected by past climate changes, shifts in ocean chemistry, and several mass extinction events. One of the biggest challenges came about 65 million years ago, when the same event that wiped out the dinosaurs also damaged marine ecosystems. But even after that catastrophe, coral reefs slowly recovered, diversified, and expanded, turning into the complex, beautiful habitats we see today. Today's reefs are vital, not just for fish and sea turtles, but for humans too. They protect coastlines from powerful waves and storms, and they support millions of people who depend on them for food, tourism, and jobs. But these incredible ecosystems are now under threat from pollution, overfishing, and climate change. Understanding how coral reefs evolved over hundreds of millions of years helps us appreciate their beauty and reminds us why we must do everything we can to protect them. After the extinction that ended the age of the dinosaurs about 66 million years ago, the oceans were wide open for new kinds of animals to explore. With many old predators gone and ecosystems changing, some mammals made an extraordinary move. They returned to the sea. One of the most fascinating changes involved how these mammals found food. Early marine mammals, like the ancestors of whales and seals, developed sharp teeth for catching fish, or evolved ways to filter tiny sea creatures like krill. Catastrophic events have played an important role in shaping the course of change in living things on Earth. These events, which can range from huge volcanic eruptions to asteroid impacts, create big changes in the environment. They can change habitats, mess up ecosystems, and lead to the disappearance of many species. This sudden disturbance often clears the way for new species to appear, as roles open up that were previously filled by leading species that are now gone. One well-known example of this is the disappearance event that happened about 66 million years ago. The impact of a huge asteroid led to the end of a large part of life on Earth, including the dinosaurs. This event, while terrible, gave a chance for mammals to change and grow into the main group of animals on the planet. From the ashes of loss came a large variety of life, showing how life can recover and change in the face of disaster. Also, these terrible events can speed up evolutionary changes such as natural selection. When the environment changes quickly, living things that have features that match the new conditions are more likely to stay alive and have babies. This can lead to fast evolutionary changes, sometimes called quick spreading and change. Species that might have stayed the same for millions of years can go through big changes when facing new problems and chances. While terrible events can cause huge loss and pain, they also play an important role in the story of life. They remind us of the strength of nature and the ongoing process of loss and change, a process that keeps happening over millions of years, shaping the many forms of life we see on Earth today. The history of life on Earth is full of times of mass loss that greatly changed ecosystems and made room for new species to appear. One of the best-known examples is the end of the dinosaurs, around 66 million years ago. This event, known as the Cretaceous-Paleogene loss, wiped out about 75% of all species. After this disaster, mammals, which had once been small and easy to overlook, began to grow in number and types. This led to the rise of mammals as the main land animals we see today. Scientists have found that mass loss events often create a clean slate for life. With leading species gone, living roles become open, allowing surviving species to change and grow. This process is called quick spreading and change. For example, after the dinosaur disappearance, mammals quickly grew into many different types, like whales, elephants, and primates. These groups developed features that helped them live in new environments, showing the power of fast evolution after disasters. Studies looking at the fossil history support this link between loss and new developments. Scientists who study ancient life say that the time right after a mass loss often shows a jump in the number of new species. In some cases, this burst of change can lead to the start of totally new types of living things, like what happened with the ancestors of today's birds, mammals, and even flowering plants, all of which became important after big loss events. The proof for a link between mass loss and later bursts of change in life is seen in both the fossil record and the way species change and grow after these big events. In the end, while mass losses are very harmful, they can strangely work as strong pushers of the growth of life, showing nature's amazing strength and ability to change. The phrase, survival of the fittest, often connected with Charles Darwin, becomes especially meaningful after mass loss events. After such huge events, the way life looks on Earth can change a lot, creating a fresh start for evolution. Species that survive must adjust to new surroundings, ways of life, and roles in nature. This means that being able to adjust becomes a very important part of staying alive in these new conditions. In a world after a loss, the living things that do well are often those that can be flexible in how their bodies work and how they behave. For instance, after the loss of the dinosaurs, it was the mammals that adjusted in many ways, leading to the wide range we see today. The disappearance made room for mammals to take over roles that had once belonged to the reptiles. In the same way, plants and smaller creatures that could grow fast and stay strong were very important in shaping new ecosystems. Also, life after a loss shows how important it is to have genetic variety within a species. A group that has many different genes has a better chance of having some members who can adjust to sudden changes in the environment. This variety acts like a store of useful features that might help if things change. A single change in the genes of a surviving species can lead to new features that help it live better in the changed world, showing how active and changing evolution is. However, survival of the fittest in these cases shows not just a hard fight, but the power of chance and adjustability. After a loss, those who can best handle the new surroundings are not just the ones who live, but the ones who help shape future ecosystems. This repeating cycle of life and death shows nature's strength and shines a light on the complex links that keep life on Earth going. Throughout Earth's history, terrible events have played major parts in shaping both the rocks and the living things on our planet. From huge volcanic eruptions to sudden asteroid crashes, these events have greatly changed the direction of life in the physical land. For example, the most famous of these events is the asteroid crash that happened around 66 million years ago, causing the end of the dinosaurs. This disaster opened up roles in nature, allowing mammals to grow and in time humans to appear. Rock shapes too have been changed by these terrible events. For example, the strong pressures and heat from volcanic eruptions can change the nearby rocks into totally new shapes. The flowing lava and falling ash create new land areas, which give special homes to different species. In the same way, earthquakes can change shorelines and mountains, leaving signs of the active processes that have shaped our planet for millions of years. After such disasters, living systems often go through big changes. After mass losses, new species grow to take the place of those that are gone. The strength of life shows an amazing ability to adjust. After the impact that killed the dinosaurs, small mammals grew and changed into the many forms we see now. In many ways, these terrible events act like a restart, helping evolution and the rise of new types of life. Also, the history of rocks written in layers shows how these disasters have changed the weather and environment. Changes in volcanic activity can cause times of warming or cooling, which affects how life changes on Earth. By studying these past events, scientists learn more about how our planet reacts to big changes, helping us understand what's happening in today's climate. Seeing the links between terrible events and the way Earth has changed helps us better understand the fragile balance of life and the forces that shape our world. Over the past few years, scientists who study ancient life, called paleontologists, have made many thrilling discoveries that are helping us understand what happened after the dinosaurs disappeared. One of the most fascinating discoveries is about the wide variety of mammals that appeared after that great vanishing. Fossils of some of the earliest mammals, such as a group known as Plesiodapiforms, show us that mammals didn't just survive, they changed and spread rapidly. During a time called the Paleocene epoch, which began shortly after the dinosaurs vanished, mammals began to evolve into many different shapes and sizes. They found new ways to live and filled many open roles in the environment. Some of these early mammals were ancestors of today's primates, and their story is helping scientists rethink how mammals eventually came to rule the planet. Another incredible discovery is about birds, the only group of dinosaurs that didn't vanish. These flying survivors of the Great Extinction event continued to evolve and adapt. During the Cenozoic era, which followed the dinosaur age, many new bird species appeared. Some of them were giants. One such example is the elephant bird from the island of Madagascar. This enormous bird couldn't fly, but it thrived in its unique habitat. Fossils of such birds reveal just how creative evolution can be. These birds help us understand how life kept going and changing, and how new species rose to fill the empty spaces left behind by dinosaurs. They also show us what ancient ecosystems were like, and how they connected to the world we live in today. Reptiles, too, had their own story of survival and change. After the dinosaurs vanished, some reptiles continued to thrive. Fossils of ancient crocodiles show that some of them were active hunters, on both land and water. These ancient crocodilians were far more varied than the ones we see today. Paleontologists have also found fossils of marine reptiles called mosasaurs, which were powerful swimmers that ruled the oceans. These animals show us that the reptile family was just as adaptable as mammals and birds, finding ways to survive in many different environments. One of the biggest influences on this new chapter of life was the changing climate. Scientists have studied layers of rock and fossils to understand how the Earth's temperature and environment shifted during this time. These changes put pressure on animals and plants to adapt, and this helped spark the rise of many new species. By carefully piecing together these ancient clues, researchers are building a detailed picture of a world that had been turned upside down, but kept moving forward with incredible energy and diversity. New fossil sites are continuing to transform what we know. Paleontologists have found rich deposits of bones and plant remains that show just how busy and alive the Earth was after the mass vanishing that occurred about 66 million years ago. This time period is called the Paleogene, and far from being an empty, lifeless time, it was full of excitement. It was a period of amazing biological experiments. Life was trying out new forms, new strategies, and new ways to survive. At these sites, scientists have uncovered fossils of mammals, birds, and even early primates, showing that the age of the dinosaurs wasn't the only important era of life. After the dinosaurs were gone, mammals grew bigger, more complex, and more specialized. Nimble, small creatures began to take over the roles once held by giant reptiles. Some mammals remained small, like shrew-like insect eaters, while others grew into huge, elephant-like beasts that would one day roam the grasslands. These finds show just how creative and determined nature can be in rebuilding itself. Even the plants changed. Fossils of flowering plants from this period show a shift in vegetation. These plants helped build rich food chains, supporting the growth of animals in these evolving habitats. Some fossils even preserve signs of animals interacting with one another, like bite marks or evidence of competition, giving us a peek into how these ancient creatures lived and survived in a world that was still healing and changing. Each new fossil site is like a time machine, offering a window into life after the dinosaurs. These findings keep deepening our understanding of how evolution works and how life on Earth can recover and thrive even after major disasters. They show us that the story of life didn't end with the dinosaurs. It simply entered a bold new chapter. The discoveries being made today continue to shine light on how all the incredible animals and plants we see now came to be. But it's not just professional scientists making these discoveries. Amateur fossil hunters, ordinary people with a passion for ancient life, have also played a key role. These enthusiasts search in riverbeds, quarries, and fields, sometimes stumbling upon fossils that professionals haven't found. They often discover new species, or fossils that help fill in missing pieces of Earth's history. Their dedication helps keep the field of paleontology growing and full of surprises. In fact, many important fossils have been found by amateurs rather than scientists. From tiny sea creatures to the bones of ancient reptiles, their discoveries are often added to museum collections and studied by experts. When these amateur fossil hunters take care to document their finds properly, they create valuable records that can help scientists learn more. Some even work closely with professional researchers, sharing their knowledge and working together on important finds. Many museums and research groups support this partnership between amateurs and professionals. They offer guidance, tools, and resources that allow amateurs to make scientifically useful contributions. This teamwork is a beautiful example of how curiosity and hard work, no matter who you are, can make a difference in science. As we keep digging into our planet's distant past, the efforts of both professionals and passionate amateurs continue to uncover more of life's long and winding journey. Every fossil has a story to tell, and together, they help us piece together the gigantic puzzle of Earth's history. However, what makes all these discoveries even more powerful is the way scientists from different fields are now working together. Experts in biology, geology, chemistry, and even physics are combining their knowledge to paint a clearer picture of the ancient world. This interdisciplinary approach helps researchers understand not only what lived in the past, but how the environment shaped those life forms. For example, By using genetic tools and studying DNA in preserved ancient remains, scientists can trace the family trees of extinct animals. They can figure out which modern species are related to those that lived millions of years ago. At the same time, geologists are using new methods to date rocks more accurately and learn what Earth's climate was like in those ancient times. By putting all this information together, scientists are uncovering how ecosystems changed and how life evolved in response. This teamwork across scientific fields is helping us answer big questions, like how climate change has shaped life, what caused mass extinctions, and how Earth's biodiversity has changed over time. These discoveries don't just tell us about the past, they also help us understand our present world and make better choices for the future. The way animals grow into giants or shrink into tiny forms is one of nature's most fascinating stories. It shows just how clever and flexible life can be when facing challenges from the world around it. These changes often happen because of the food that's available, the kinds of living spaces, called niches, that animals move into, and the different pressures brought on by weather, climate, and geography. For example, imagine a small island with no big predators. Some animals living there may grow much bigger than usual. This is known as island gigantism. Without danger from predators and with fewer competitors fighting for the same food, animals like birds or rodents can become much larger than their cousins living on the mainland. It's as if the freedom from fear allows them to stretch out and grow. On the flip side, there is also something called island dwarfism, where animals become much smaller. If there isn't much food on an island, being small becomes an advantage. Tiny bodies use less energy and need less to eat, which helps them survive in places where bigger animals might starve. For example, small reptiles or rodents on such islands often stay small or even shrink over generations to fit their environment better. But size changes don't only happen on islands. All around the world, climate and habitat also play a big role. During the Ice Ages, which began more than 2 million years ago and lasted for millions of years, huge animals like woolly mammoths roamed cold, grassy plains. These giants thrived because the cold climate and abundant vegetation supported their massive bodies. The chilly air also made it useful to be large, since bigger animals can keep warm more easily. In warmer parts of the world, though, smaller animals often do better. Being small helps them stay cool and move quickly through thick forests or dry savannas. It also helps them escape predators or hide in small places. Whether animals grow to towering sizes or shrink to fit in tiny spaces, these changes are part of evolution, the slow and constant process of adapting to survive. These changes show how life responds to its surroundings, always looking for ways to thrive in new and changing environments. About 66 million years ago, something big happened. A massive asteroid crashed into Earth, wiping out the dinosaurs and about 3/4 of all life. With the giant reptiles gone, Earth's ecosystems opened up. This gave mammals a golden opportunity to rise and take over the spaces dinosaurs once ruled. During a time known as the Paleocene epoch and the periods that followed, mammals began to grow and change rapidly. One major trend was the rise of large mammals, some of them growing to enormous sizes. Why? Because there was suddenly a lot of food to eat. Without the dinosaurs chomping on everything, plants flourished. This green explosion created lush forests and grasslands full of food, which could support bigger and bigger plant-eating mammals. Creatures like the woolly mammoth or the giant ground sloth could grow so large because the plants around them were plentiful. These animals had no trouble finding enough to eat. In fact, their size often helped them eat more efficiently, reaching taller trees or travelling longer distances to graze. But being big also came with other benefits. Larger animals usually have fewer enemies. Their size can scare off attackers, and they're often better at defending themselves. Big animals are also better at keeping warm when the weather gets cold, which was very helpful during the chilly ice ages, and when food was scarce they could walk far to find new supplies, while smaller animals might not make it. This trend toward bigger bodies didn't happen in every mammal group, but it appeared in many. Over time, Earth saw a wide variety of giant mammals take shape, each adapted to their own unique environment. Gigantism became nature's experiment, driven by food, fewer predators, and changing climates. These magnificent creatures walked the Earth for millions of years until new environmental challenges and climate changes brought their reign to an end. As Earth's climate changed over millions of years, so did its plants, also known as flora. Shifting temperatures, rainfall patterns, and even the position of the continents transformed the landscape into forests, grasslands, swamps, and deserts. And as the plants changed, so did the animals that depended on them. In thick forests where plant life was dense, smaller mammals had the upper hand. These little creatures, such as rodents or tree shrews, could quickly dart through tangled branches, climb trees, and squeeze into small shelters. Their size helped them avoid predators and reach hidden food like berries, seeds, and insects. In these leafy jungles, being small was not a weakness. It was a superpower. In open grasslands, however, a different kind of animal took the lead. Out on the wide plains where trees were few and far between, larger animals like elephants, antelope, and bison began to thrive. These huge mammals were built for travel. They could roam across long distances searching for grasses and water. Their size gave them strength, helped them fend off predators, and allowed them to store energy for tough times. In this way, plants helped shape the animals around them. The kind of vegetation in an area determined what kinds of animals could live there, and how big or small they needed to be to survive. This back-and-forth relationship between plants and animals is one of the main forces driving evolution. As the world continued to change, so did its plants and creatures, always adapting to one another. Together, they created the rich, diverse web of life that we see across the Earth today. Another powerful force that has shaped the size and variety of life on Earth is the slow, steady movement of the continents. Over tens of millions of years, the giant plates of Earth's surface have drifted apart, collided, and rearranged themselves. This movement, known as continental drift, has broken apart ancient lands and formed new ones, causing species to become isolated from one another. When a group of animals gets separated by water, mountains, or deserts, they often evolve in their own unique ways. Over time, they can become entirely new species. One of the most famous examples comes from the Galapagos Islands, visited by Charles Darwin in the early 1830s. He noticed that the finches on each island had different beaks, perfectly suited to their diets. Some ate seeds, others insects, and a few even drank the blood of other birds. These differences had evolved because the birds were isolated and had to adapt to the resources available on their individual islands. This same pattern has been seen in the evolution of animal size. In isolated places, some animals get bigger than their mainland cousins, while others shrink. On islands in the Mediterranean, for example, ancient elephants became dwarves, far smaller than their mainland relatives. With less space and fewer resources, being small was simply smarter. In contrast, on some islands without predators, birds or lizards grew bigger because there was no danger and more room to grow. These examples show how being cut off from the rest of the world, whether by shifting land or rising seas, can spark amazing changes in animals. Continental drift didn't just move the land, it moved the story of life in new directions, allowing evolution to try new things in new places. From shrinking rodents on tiny islands to towering mammoths on icy plains, the size of animals has always changed based on where they live and what they need to survive. Whether shaped by plants, predators, temperature, or isolation, every size shift is part of evolution's grand experiment. These stories of growth and shrinkage, of new environments and vanished ones, remind us of how alive and ever-changing our world really is. Evolution is not just about survival. It's about thriving, adapting, and becoming something entirely new when the world demands it. Across oceans, deserts, forests, and meadows, life continues to change. And through these changes, we see the true wonder of nature, its endless ability to adapt, endure, and surprise.